Hello, everyone. Good evening. I think we can start. Okay. So first of all, quick update of what's the progress on string questions. Is that solved? Is there any doubts? No. There was one question, distinct palindromic substring. That's something we'll discuss. Apart from that, do you have any other doubts? Or all the questions are solved? All good. Good strings only. Good strings, I guess we solved yesterday, right? Good string to solve कर दिया फिर हमने. I remember we solved it.
सर स्ट्रिंग कॉम्प्रेस रन नहीं हो रहा है फिर भी
It's a string compress.
टाइम एक्सेस दिखा रहा है
ठीक है. I guess इसको भी सॉल्व करा था हमने. Are you seeing NZDC, that issue? Okay, that might be one thing, which is again because of string concatenation that we can't resolve. Okay, so anyways, we have StringBuilder, so that will do this. We'll do that. So that will resolve all string concatenation issues. There doesn't in string identifier. So you can think it like string problem. Try to think it like arrays itself, right? Just that the manipulation and all these things are a little bit different. Okay, so we'll discuss that. So I guess we have few doubts. So we have distinct palindromic string, good strings, keyword bitized, right? So okay, we have 3-4 doubts. Okay, a good number of doubts. So let's start with sorting. Okay, let's first start with sorting, and then we'll come back, revisit strings, and we'll complete this discussion. Okay. Just a second. Yeah, let's spin it. Okay. So yesterday we started discussing sorting, right? So I told you about basically like sorting is used in a lot of places, right? Sorting has a lot of implication, a lot of usage. So sorting is basically family used in a lot of places, and we have a lot of practical applications of sorting. Now, since there are so many sorting algorithms that's there, it becomes very much critical to know all these algorithms and to run the best algorithm given the scenario. So for example, you are given any scenario, you have to figure out the best algorithm that would fit here, right? The best algorithm that suits this question, or the algorithm that would give you the best complexity in that situation. So you'll see the first few ones, so that will give you idea of how we think, right? How we can think, and then how we can think out of the box to sort things, which is like analog and algorithms, right? So there are so many of them, right? So each one is different. Okay, so we'll start with one of them. So I also gave you an idea of about like counting sort, what counting sort is, and what is its limitation. So discuss basically sorting is nothing but something like which can sort a list of any list of numbers, any list of strings, any list of decimals, and all those things. Now, in case of now in case of so we applied one basic sorting algorithm, which is counting sort, right? So let's say we know the range of numbers that's present. So what we can do is we can count the number of numbers in this particular range, and then we can print them, right? So for example, if we got 3 2s or 2 3s or 5 8s, so we can print them in the order, and that would also print the sorted list. So this is one way to sort, which is which works in order and time. This is order and loop, and this is also an order and loop, right? Because we are just printing it. So this print operation will happen only n times. That is the number of numbers in the array. So this is again an order and loop, and this is also order and loop. So we can sort it using order and logic, but there is a lot of constants, right? This won't work if the numbers are negative. You have to do some hacks, right? If there are very large negative, the range is very large, for example, minus 10 to the power 8 to plus 10 to the power 8 or something like that. You cannot create arrays of those size, right? If numbers are in range of 10 to the power 18 or something, the arrays cannot be created. So same goes for, you cannot have strings sorted in this way. You cannot have decimal numbers sorted in this way. You cannot have sort this if arrays values are very large. So there is a lot of limitations on this. So this cannot be applied in all the places. If it can only be applied if you know the values and if the values fit in particular range. So this sorting is known as counting sort, or we call it as bucket sort as well. And this sorting algorithm has a complexity of order n. Okay, and this is the only sorting algorithm to have a complexity of order n, but we cannot use it in all the places. Okay. In array rotation, we sort it with if else. We did not sort it. We basically try to, in array rotation, we were not actually sorting it. We were just trying to rotate it, right? We're not sorting it. Sorting is the last one. Yes, we just have one string builder and buffer reader. That concept. Apart from that, this is the last one. Okay. Now let's see how we can sort, right? So these are all the ones, all sorting algorithms that I'll like cover here are the ones of how you sort actually. So how you would basically generally apply sort in your real life. Okay. So let's say you are given an array of numbers. Okay. And I tell you to apply sorting in this numbers. So let's say you have 1, 5, or let's say 10, 5, 2, 1, 8, 3, 4. Okay. These are the numbers. Now, how will you apply sorting on these numbers? Okay. Okay. So what does selection sort do? Let me explain that. So selection sort is very easy, right? One of the most simple and easiest sort is selection sort. So what we do in case of selection sort is we pick the first number. Okay. So this is the first number. Let's say 10. And we'll assume that this is the smallest number, this is the first location, right? So first location should have the smallest number. If the numbers are sorted in ascending order, so this should be the smallest number. Okay. So if it follows, if it is correct, right, this is the smallest number, we don't need to do anything. But if it is not the smallest number, then this is not in its correct position, right? This position should belong to the smallest number in the array. Okay. So what we'll do is we'll consider, let's say minimum number is the first number 10, and then we'll validate whether this is actually the smallest number in the array. So how will we validate? By comparing. So we'll go through the entire array, we'll compare. Is it smaller than 5? No, it is not smaller than 5. Then we'll say, oh, 5 might be the smallest. This is not the smallest one. We'll check with 2. So no, 2 is also smaller than 5. So 2 might be the smallest. This is not the smallest one. Then we'll check with 1. Oh, 1 is smaller than 2. So 1 might be the smallest. This is not the smallest. 2 is not the smallest one. Then validate, is 1 smaller than 8? Yes. Is 1 smaller than 3? Yes. Is 1 smaller than 4? Yes. So ultimately, basically, we found out the minimum in this entire array. Starting from the first index, we found out the minimum. Now, once we got the minimum, where this minimum should belong, the correct position of this minimum is the start of the array. Right? It should not be here. It should be at the start of the array. So we'll basically swap these two values, 10 and 1. So we know how we can do swap, right? So if let's say I give you two index 0 and index, let's say 3, 4, whatever it is, 3. Okay, if we have to swap these two index values in the array, we can do that, right? So that's a simple logic. A of let's say 0 is equals to a of temp is equals to a of 0, a of 0 is equals to a of 3, a of 3 is equals to temp. That's simple logic. Okay. So now if we swap it, 1 comes over here, 10 goes over here. The remaining array remains still same. Is it sorted? No, it's not sorted. Sorry. Just 10 would be here, 8 would be here, 3 would be here, 4 would be here. Okay. Is it sorted? It's not still sorted, but we have got one number at least at the correct position, which is 1. Yeah, ascending order, right? I'll explain the ascending. Descending is very easy, right? So let's only understand the ascending. Descending, if you understand ascending, descending, what is automatically very easy. Okay, so now what we actually did is we brought 1 to its correct location, which is the minimum in the array. Okay, 1 is at the correct location. Understood everyone? This one, this logic. So basically we traversed the entire array, found out the minimum number, put it into the first place, which is its correct position. Okay, now which number should belong in the second position? The second smallest number, right? Now how will you find out the second smallest number? See, so when you found out the first smallest number, when you found out the smallest number, you traverse the entire array. Now, since you have moved the smallest number to this particular location, which is at the start of the array, right? So what you can do is you can start looking for the smallest number from I plus 1 to n. From index 1 to n, you can start looking for the smallest number. Whatever is the smallest number in this particular range. So let's say this second time it also look at 2 is the smallest number. So what you need to do is you need to swap 2 with 5. So you'll bring 2 over here, 5 over here. Now you got smallest at the first location, second smallest at the second location. Now similarly, you'll cut this part of the array. Now you start looking smallest number in this part of the array. Whichever number you will get smallest, you got 3 as smallest, you will change 3 to here, 5 to here. Understood? Understood the logic? So basically, we are decreasing the array size by 1, finding the smallest in that number and bring smallest in that array and bringing it to the start. Simple logic. Okay. Let's see how difficult is it to code this out. So this is very simple logic. We can easily code it out. So let's take this array itself as example. Control C, Control V. Okay. Let's check. So we can go for 4. Int I is equal to 0, I is less than n, I plus. Okay, so what we can do over here is, so what's the number that we assumed is the smallest? Let's say index I. Okay, we'll show its index, so it's easier to swap as well. Okay, so here now you assume the number at index I is the smallest. Now we want to compare it with all the numbers from j plus 1, I plus 1 to n, right? It should be smallest from I plus 1 to n. So for index 1, it should be, we assume that this is the smallest number. We'll compare it with all the numbers over here. We'll check whether it is smallest. If not, then we'll find out the correct smallest number in this range from I equals to 0 to n. Okay. So we'll check if minimum of this is greater than a of j. That means a of j is smaller than this. So that would be the smallest. So we'll store minimum is equals to j. We'll do this. Now, after this loop is done, that means what we will get? We will get the smallest number in this array starting from 0. We'll get an index which is stored in minimum, which is nothing but smallest number in the array starting from 0. Now we just need to swap it to bring it to the start of the array. So a of temp is equals to a of I is equals to a of minimum. A of minimum is equals to temp. Then now if you print this array,
Hello, sir.
Yeah.
So I should be less than n minus 1, sir. Otherwise, j would be out of bound.
It won't run for that situation. It won't run. This loop won't run. So it won't cause a problem because of that. But we can do it 1 minus 1 to reduce one iteration. So I'll explain that why we can do it. See, it won't be out of bounds. It's fine. Okay. Okay.
Sir, line number 26, 52.
2652. This one. Yes. Okay. Let me explain what we have done. Let me do a try run. Okay. See. So what we have done is, see, so we took this entire array. Okay. Now our I is over here. First time I is over here, which is index 0. Now as I told that this is the minimum I. So what is minimum? Minimum is equals to 0. So I told that minimum is pointing to the index 0. Minimum is present at index I, which is index 0. This is where the minimum should be present if the array is from 0 to n. Right. Now we started by comparing from ji is equals to I plus 1. We started from here, right? And we checked whether whether the value at this index is greater than j. Whether the value at this index 0, whether a of 0 is greater than a of 1. Is it true? Is 2 greater than 6? No. So minimum is this index. Okay. Next iteration, we increased j came to here. We got this value. Now we compared is 2 greater than 1. Yes, 2 is greater than 1. So we pointed minimum to index 2, right? Okay. Then we again increased j. We compared is the minimum. Okay. We compared is the minimum greater than this? No. Minimum is index. Minimum is pointing to the index 2, which is having value 1. Is 1 greater than 10? No. Next iteration is 1 greater than 3? No. 1 greater than 7? No. 1 greater than 3? No. So none of the conditions satisfies from here, and we end up when minimum is equals to index 2 and I is pointing to index 0. So basically we end up in such a situation. Minimum is here and index is here. See, what we did is we basically did not change I. I is pointing still to the first index. We just find out that we assume that this is the minimum, but we checked, right, from in the entire array whether this is actually the minimum. If it is not, then which is the minimum in the array? Minimum will be storing that index, right? Similar to like finding out the minimum in the array, we just stored the logic to that. Okay, instead of storing that minimum, just store the index. Now, what did I do with this? So we actually swapped these two values by using this logic. So I is pointing here, minimum is pointing here. We just swapped them. So 1 came to here and 2 came to here. So now see, after the first traversal of this, after this J loops runs for the first time, what we got is we actually got the like first index storing the minimum number. First index is storing the minimum number. Okay. Okay. Now how is this swap working? So we just created a temp which is storing a of I. A of I was 2. We just pointed a of I which is 0 to store the value which is present in minimum. So a of 0 became 1. So this got overwritten by 1. Now we stored a of minimum which is index 2 with the value that's we stored in temp, so equals to 2. So a of minimum this became 2. So there's two values swapped. So this is like the normal swap logic, right? How will you swap two values in array if you know the index? So this is how we would swap. Okay. What is going to happen in the first iteration of this? Understood? Doubts? No.
Sir, line 2656 and 2657.
ये दो lines. So this is the swap logic, right? अगर मुझे पता है minimum ये है और mn ये है, ठीक है? So how do we swap these two values? We know two index in the array, but we want to swap their values, right? So how will we do it? So we created a temporary variable which will store a of I. A of I is having value 2. Okay. Now we pointed a of I which is index 0. A of 0 is equals to a of mn. What is a of mn? 1. Okay. We are interchanging the value. Yes, swap means interchange. We are just interchanging the value of these two places. We just change this value. This came over here. Now a of mn which is 2. A of 2 is equals to a of temp. Sorry, a of minimum is equals to temp which is value 2. So see, a of 0 stored the value 1. A of 2 stored the value 2. So a of 0 changed its value to 1. A of this stored changed its value to 2. So these two values were swapped. Okay.
Sir.
Yes.
How it's giving not out of bounds if we run the first loop till end, till the last.
So when this is n-1, when I is equals to n-1, what is happening is we are trying to do this j is equals to I plus 1. So j is equals to n. Okay. So j is equals to n, n less than n. Is this condition satisfied? No, we never enter into this loop altogether. Okay. We don't enter into this loop. So minimum is also pointing to I and we have the value as I. So when so basically assume that if 1 was present already over here or we never enter into this loop. In both the situations, what we'll do is we'll point temp is equals to, let's say, a of whatever index, n-1. A of n-1 is equals to a of n-1. And then we again do a of n-1 is equals to temp. So what is this changing? Nothing. No swap is actually happening and that value is remaining at that index itself. And this loop never ran. Okay. That's why we won't get out of bounds.
Okay, sir. Okay. Got it.
Okay, so now this actual array was sorted. See, it's array is sorted. Actually, the same array was sorted. Right? Temp is just a variable, right? How can temp be sorted? So the actual array was sorted. Now, when we are printing the actual array, we see the array is getting sorted.
So if we have 0 at the last index, so will it change?
If we have 0 at the last index.
Yeah.
So this would still be able to find it, right? See, when we are traversing this, it will be finding the smallest value in the first, right? See, so first iteration, it will try to do and will try to find out the smallest value. So I will be over here and then mn will be pointing to this, right?
But one is less than 2, right? So it will swap for the first time or it will check for whole array.
In the first time, it will check for the whole array, right? So in the first time, it will check for the whole array. It will and then it will find out the minimum in whole array. It will put it over here and 2 goes to here. Next iteration, when I becomes 1, so we are now not checking in the whole array when I actually becomes 1. So now we will find out the minimum in this array starting from 1 to here. Check. Okay. So now this time when I becomes 1, what we are doing is we are assuming minimum is equals to 1 and we are checking from j is equals to I plus 1, which is index 2 to index n. We are trying to find out the minimum in this range. And once we get the minimum in this range, we'll just swap its value with this index I. So the minimum, if whatever is the minimum in this array, that should go over here. So we'll get 1, we'll put over 1 over here and 6 will change it. Right. So now next iteration, we'll again do the same thing over here. Okay.
So sir, means sir, every iteration, every element got their correct place in ascending or descending order.
Right. So in every iteration, we are finding out the correct place for one element, right? So think it like this. So think it like a paper. Think like you have a deck of cards. Oh, I have a deck of cards that I can show you.
Sir, you are on mute, sir.
Oh, sorry. So let me figure out few numbers from this text so that I can show you what is actually happening. Okay, this is fine. So let's say, let me know if you are able to see this. Should be able to see this. Are you able to see this numbers? Yes. Okay. So see, what we are doing is we are starting from this index. Okay. Let's assume this is a start of array. Okay. So this is a start of array, which is it mirror image for you, or is it like showing in the correct form numbers? I guess should be showing in correct.
Sir, fine, sir, fine.
Fine. Okay. Okay. So the first number is 9. Okay. So what we are doing is we are assuming that this is the smallest one. Okay. Now we assume that this is smallest, and necessarily this is not the smallest one. We'll compare it with every number, right? So we'll check it with 8. Is it smallest? No, 8 is the smaller one. So we'll now get 8 is the smallest one. We'll compare then. Okay, is 8 smallest one, or is there any number smaller than this? So we'll check. Okay, is 2 small? Okay, 2 is the smallest one. So till now we got 2 is the smallest one. Then we check 3. No, 3 is not smaller than 2. Then we check for 7. 7 is also not smaller than 2. We finally got that 8 is, so 2 is the smallest number in this array. If we start from 9 and we traverse through the entire list. So what we'll do is we'll swap 2 with 9. Okay, so we'll take 2 out from here. We'll put it at the start index and we'll put 9 at the place of 2. Okay, now 2, after one iteration on this entire array, after we did one entire iteration, what happened was 2 came to its correct position, 9 went in the place of 2. It may or may not be its correct position. We'll later figure out whether it's a correct position of 9, but 2 got its correct position, right? So that's what we are doing. So we took 2 out from here, right? And we checked, we assumed that 2 is minimum. We checked in the entire array. Is it actually minimum? If there is any number smaller than this, we got 0. 0 is the smaller than this. So we swapped its position with this. Now 0 came to its correct position. 2 went to some random position, which may or may not be its correct. Now next time when we'll start our sorting, what we'll do is we'll know that 2 is already in the correct position. So we don't need to do anything on this 2. We'll start from here, that's index 1, and we'll start checking. We'll assume 8 is smallest. Is there any number smaller than 8? We check with 9. No, 9 is not smaller. We check with 3. Yes, 3 is smaller. So 3 is the smallest right now. Is 7 smallest? No, 7 is not the smallest. So 3 is the smallest, and it should be over here instead of 8. So now we'll swap 8 with 3. Okay, now 3 would actually come to its correct position. See, now you'll see that it is actually getting sorted, right? 2 and 3 got its correct position, and this part is not sorted, right? They are in random fashion. So next time we'll check for array of 3 and we'll try to sort these 3 numbers out. Okay, understood? Yes, yes, I do play some cards that I have.
So,
yeah, yes. Say.
So initially, 8 and 9 will should be swapping now.
8 and 9 should be swapped.
Because
no,
9 and then after 8.
No,
Then
actually, no, we
why
are
this-
not looking for the smaller number. So for example, let's say we have let's say we have 12 over here. So 6 is the next smallest right away you get, right? So we don't swap it right away. We actually traverse the entire array. हम पूरे array को traverse करेंगे और smallest find करेंगे, right? Because at the first index 6 will not be over here, right? 6 यहाँ पे हो भी सकता है, नहीं भी हो सकता, right? Because there can be a smaller number than 6 in this list. If we get 1, ठीक है, let's say we started with 2 and we got 1, ठीक है, so we will not be swapping 1 because there might be a 0 over here. 0 is the smallest one, or there might be a negative number. So we don't know, right, what's the smallest one. And so what we'll do is we'll select the smallest number, bring it to the start. So that's why it's known as selection sort. What we are selecting the smallest number in the array, bringing it to its correct position. Okay. So when you had, like we had 8 and 9, so we also had a 2, right? So you have to go to 2 and bring it to the correct position. 8 will sweeping to there, which is not going to its correct position. Now understood? Can we check for a swap operation? That is also something which you can do. Right. So here the swap is actually not happening if I is if I is not equals to mn, then only you need to swap. If this is not there, then you don't need to perform this. So this is something if you want to put, you can put it. No difference. This won't cause any difference over here. Okay. Understood? Easy, simple logic. Okay. So when should we use selection sort? So this is like the very basic sorting algorithm, right? So we there is, I'll say there is optimal sorts than this. So if we ever prefer an n-square sorting algorithm, we'll prefer insertion sort. But this is where we can start thinking, right? So you can understand how sorting is working, right? How different algorithms are. So this is like fairly straightforward. We already know how to find out minimum. Just that we are finding out minimum, putting it into its correct position. We take entire array to find out minimum. Then we say, oh, let's start from I equals to 1 and find out the minimum over here. Then we say, oh, let's start from I equals to find out the minimum over here. Now see, okay, if you run this loop even till n-1, you would still get correct result.
सर कोई practical example दीजिए ना सर, कहाँ use होता है selection sort?
So I would say it would be used in such a places where you don't want to sort the entire array, but you want to get, let's say, sort first 3 numbers. Okay, first 3 numbers of the entire array. Now in any other sorting algorithm, let's say कि अगर हम हमारा ऐसा कोई requirement है, let's say कोई ऐसा filter बनाया हमने कि there is a very long list. ठीक है. Now if user applies that filter, I'll just move the smallest 3 numbers or largest 3 numbers at the start. ठीक है, मुझे बस ऐसा करना है, पार्शियल शॉर्ट करना है, 3 या 4 नंबर या 5 नंबर को शॉर्ट स्मॉलेस्ट नंबर को स्टार्टिंग में रखना है, रेस्ट नंबर्स कैन बी रैंडम. ठीक है, इफ दिस इज द रिक्वायरमेंट देन सिलेक्शन सॉर्ट इज द बेस्ट. क्यों? Because in any other sorting algorithm you cannot you will be sorting the entire array, right? It won't put the smallest or largest. The bubble can do it, but bubble has a lot more swaps as compared to selection sort. Selection sort में अगर मुझे 2-3 numbers correct position पे लाने, right? If we just want 2-3 numbers to go to its correct position, then this is the best sorting algorithm. Okay, so that is one case where selection sort would be better than any other sorting algorithm. If you have to partially sort, or you exactly know you have to put 3 or 4 number 3 or 4 sorted number into its correct position. Okay, got it? So in that case, you just need to run this I loop that many times, right? So for example, if you want to sort only 3 numbers, so let's say I just want to sort 3 numbers and put it into its correct position, rest part of the array can be random. Okay, so I can run it for 3 times. What you would observe is, let's see, the first 3 numbers are correct, it is sorted, which is also in this correct position in the entire array. Right now, the remaining are random numbers. Okay, so where do you need this logic? So there might be filters that you might be designing. There might be like, for example, so we apply this in places. For example, let's say on sites you don't see the entire list. So for example, Google search, right? When you perform a Google search, we have so many results that Google doesn't show you all the results. It shows you results only of the, let's say, like first 10 results in the first page, and then the remaining results are at the next and next page, right? So all those results you're not even able to see. Now when you would apply sorting, right? Let's say Google creates a filter, like you want to sort it by date, right? Date of the article. I don't know whether Google has it. I have not seen it, right? So if, let's say, Google allows you to sort the results based on the date, right? And you are just seeing the 10 results out of 50 results, you are just only seeing 10 results. Okay, you are seeing only 10 results, and there are, let's say, 100 or 1000 results that you got when you search something. So if Google just applies sorting on 10 results instead of 1000, you would still be fine, that because you are only seeing 10 results, you are not even seeing the remaining 100 results. And most of the time 99% users never go to the second page of Google ever, right? If you are going to search something on second page of Google, then that's how many times, honestly tell me, you would have ever visited the second page of search result? Never, right? Mostly 99% of the times never. Few times you might have gone to like the second page, or third, fifth, or 10th page you might have never gone, right? So there is like one very few people who would go it, and even if you go, right, so that you can sort that point of time. If you go to the second page, third page, you are still seeing only 10 results in those pages, right? So you don't need to apply sorting on 1000 pages. If you just apply sorting on 10 numbers, you're fine. And this is going to work faster than any n log n sorting algorithm, because you're just doing 10 or like 10 n times, right? You're just running the loop for 10 n times. Understood? You're not sorting the entire array. So that's like that's not using any additional space and sort thing. So selection sort is very efficient if you know, like if you just have to sort a fraction of it, you don't have to sort the entire like array. Okay. Understood? Okay. So yeah, so this is the application of selection, and this is what is very simple, very naive. You have a list of numbers, you just apply a sorting on it. Okay, got it? Can we move to the next sorting algorithm? Is this done? You have doubts? Line 25 I is written, I should be less than equals to mn, ये लिख सकते हैं. So this is index, right? ये index है. These are not the value. If you want to check greater than less than that, you can check using for a of I, a of mn, right? वो value है. These are the values a of I, a of mn. I or mn thus represents index, right? So not equals to is fine, or you can check I should be less than mn, right? If it cannot be greater than mn, I can never be greater than, and if it is equal to, then you don't need to swap. Right? So if it is less than, then it's fine. Achha, tell me why if we run it till like n-1, then also it will get sorted. If I run it till n-1, then also it's getting sorted. Why?
Because other than last element, every element is already sorted within n-n iteration.
Right. So if you just put n-1 elements into its correct position, the last element automatically goes to its correct position, right? So you don't need to run it for like, okay, I forgot to mention the date again. So let's add the date. Today's date is 24th, I guess, or 24th. 24th March and 2023. So if you sort n-1 element, the last element automatically gets sorted, right? Understood? Okay. So this is it. This is your what I would say. This is your selection sort. Shall we move to the next sort? Bubble. Okay. Okay. So now bubble also follows a similar kind of strategy, but little bit different, right? Selection में क्या करते हैं? We were selecting a particular element and we're bringing it to its correct position. Okay. Bubble says कि let's not do this. What I would do is, if I see anything out of order, right? So for example, if there is anything out of order in this, so let's say, let's take it in this way. Hey, let's assume this array, right? Same array. We want to apply the sorting on same array. So what bubble would do is, it will compare any two consecutive numbers, right? So we'll compare 2 and 6. Let me write it over here. 2, 6, 1, 10, 3, 7. Let's write just 4, 8. Okay, let's take this array. So what it will do is, it will just check any two elements. If they're in the correct order, they should be in the ascending order. If it is, yes, they are in the correct order. In ascending order, 2 should become before 6, and that's fine. Okay, so we'll not disturb anything over here. Then it will compare these two elements. Are they in correct order? If they should be in, if they're in the ascending order, let's say yes, they're in the correct order. If they should be in the ascending order, then it's oh no, sorry. So 1, 6 and 1 are not in the correct order, right? If they should be in the ascending order, this is not the correct order. So what we'll do is, we'll actually swap and we'll bring these two into its correct location. So we'll swap, 1 will come over here, 6 will come over here. Okay. So every time any two consecutive elements are not in the correct order, we'll swap them. Now we'll compare 6 and 10. Are they in the correct order? Yes. We'll compare 10 and 3. Are they in the correct order? No. So 10 and 3 are not in the correct order. We'll swap them. Okay. So 3 would come over here, 10 would come over here. 10 and 7, is it in the correct order? No. So we'll swap it. Okay. So 7 would come over here, 10 would come over here. 7 and 4, sorry, 10 and 4, is it in the correct order? No. So we'll swap them. So 4 would come over here, 10 would come over here. 10 and 8, is it in the correct order? No. So we'll swap them. 10 would come over here, 8 would go, 8 would go over there. Okay. Now finally, are they in the correct order? Yes, they are in the correct order. Now what happened due to one traversal? Did the array get sorted? No. But what happened actually was the last number, right, came to its correct position. So the largest number went to the last of the array, right? So here earlier we are finding smallest one, putting it to the start, but when you swap two elements which are not in the correct order, it would bring the largest element to the end of the array, right? So largest element would bubble up to the end of the array. Like if you do it for the second time, second largest would bubble up to the second last position, third largest would bubble up to the third last position. So let's do it once more, right? So this time largest is already at the last index, right? Now if we do this operation again, we'll compare these two. Is this in the correct order? No. So let's swap them. Okay. So we'll swap 2 and 6, 2 and 1. So 1 and 2 will come over here. We'll swap then. We'll check 2 and 6. Is it in the correct order? Yes. We'll check 6 and 3. Is it in the correct order? No. We'll swap them. Okay. So 3 would go over here. 6 would come over here. 6 and 7. Is it in the correct order? Yes. 7 and 4? No. So 7 and 4 is not in the correct order. Sorry. 6 was here. 4 and 7 would come over here. 7 and 8, is it in the correct order? Yes, we won't swap them. 8 and 10, is it in the correct order? Yes, we won't swap them. So see, first iteration 10 came over here, second iteration 8 came over here. We did not read swaps, but that's fine. So 8 came over here. So now we put 8 into its correct index, 8 into its correct position. Okay. So this is bubble sort. What it is doing, so in selection sort, we are selecting one element, putting it into its correct position. In bubble sort, we are swapping continuously so that we bubble the largest element to the end of the array. Okay, so we bubble the largest element to the end of the array. Understood? Okay. Like so you can do it by selecting it, but this is like a different strategy, right? Where you are bubbling up this element to the end of the array. Selecting and putting would again be a selection sort, right? If you are selecting something, putting it into some position, that would be selection sort. That maybe you can put it into the start, maybe you can put it into the end, but that is again still selection sort. So if I start putting largest number to the start, that would be selection sort. We would sort it into descending order.
So which one is faster than selection sort or bubble sort?
So both of them complexity wise are n square. I'll talk about time. I'll compare both of them, but both of them complexity wise are n square. Just that selection requires less number of swaps. Bubble require more swaps, right? So bubble is having more number of swaps. So we would prefer selection over bubble. We should be preferring selection over bubble. Bubble is, I would say, bubble is having the least amount of application practically. Okay, selection still has some applications where you want to do partial sort. You can prefer selection, right? But bubble is actually not at all preferred because of having too many swaps. Okay, that's one reason we have too many swaps, and it is n square, right? In worst case, average case, every case it is going to n square. There is one scenario. Okay, there is one scenario I'll tell you when you should be preferring bubble. It is easy to write, but there is one scenario I'd say there is a little bit thing that we can change in bubble, and we can actually okay, let me tell that. Okay, so let's write this logic and I'll explain that part. Okay, so what we are doing over here, we can start from 0 to n, and how many times we need to do this operation. Okay, so we need to, on the first traversal, largest will go to the last, second traversal, second largest will go to the second last, third traversal, third largest will go to the third last, so on. Right, so we basically need to do this operation n times. Okay, so we can run the outer loop from 0 to n. Okay, now we can run the inner loop from j equals to 0, j less than n minus 1. Why n minus 1? Because no, bubble is increased in DSA syllabus. No, see, this is just logic, right? It's easy to remember. If you just know what it is doing, you can write this logic yourself. There is nothing to remember over here. इसको mug up करने की जरूरत नहीं है. There is nothing to mug up. You already know to find out minimum. You just need to swap it. I told you the logic to compare to value swap it. Right? So you know this logic to swap. You know how to handle this edge case of overflow or something. See over here. So what we did, we just took two numbers, we checked. So why I have ran this for n minus 1? Because when we are checking for consecutive number, for the last index, it would be out of bounds, right? So for that, we are running this loop for n minus 1. Okay. Now, see, earlier we did not need to do it because this I plus 1 was in the initialization. This condition will get checked after we do this, right? And inside this, I'm never checked j plus 1, but here I am checking j plus 1 inside this loop. So if the condition might be true, but this would still overflow, right? This might still overflow. right? Why j equals to 0? Because we always have to start from the starting, right? We always have to start from the starting and we'll go to the last index. Okay. We cannot put j equals to I plus 1 because we want to always start from the starting and go to the end. That is one optimization, j less than n minus I minus 1, that we'll do. But let's do it firstly without optimizations, which is this, right? We can say, can take temp is equals to a of j. If this is not in order, if a of j is greater than j plus 1, that's not in order, right? So we can take a of j is equals to a of j plus 1, a of j plus 1 is equals to temp. So basically swap it. Now at the end, if we just copy this and paste it over here, done. Okay, let's run this. Okay, so we get the sorted array, right? So what happened over here? Let me do a quick try run. Okay, let me just do this. Copy this thing, comment it, paste it over here. Okay, see. So what we are doing over here is we basically compared into consecutive numbers. 2 and 6, are they in order? Yes. 6 and 1, are they in order? No. So immediately swap them. So 1 came over here, 6 came over here. 6 and 10, are they in order? Yes. 10 and 3, not in order. So 3 came over here, 10 came over here. 10 and 7, are they in order? No. So 7 came over here, 10 came over here. 10 and 3, are they in order? No. So 10 came over here, 3 came over here. Then we kept on swapping 4, 10, 3, 10, 3, 10, 0, 10. So finally at the end, 10 came to its correct position and all the other numbers were not in the correct position. Next iteration, when we do it again, the second largest will come over here. Next iteration, when we do it again, third largest will come over to the third position. Fourth time, fourth largest will come to the fourth position. Okay, so we just did the swap logic that we did earlier. Now just that we are swapping two consecutive numbers, j and j plus 1, which is actually swapping this result. Okay, understood? How is this working? J equals to I is going to affect, right? J equals to I. So for example, next iteration we should be starting with this. If you just put j equals to I, that is not going to sort it, right? That's going to be some random.
எல்லாரையும் பிடிக்கும்தானே நமக்கு.
Okay, so if we just put it, see, so this is random, right? This is not sorted. This did not sort it. If you put this, it will not sort it. Only the first number would go to the largest correct position. Then you might see random results, right? So j equals to I is not a solution. You always have to start with starting, right? So numbers are going to the end. Why did we start with in the previous case? Why starting with I plus 1 did not change anything? Because we were thinking, so the smallest was coming to the first position. We don't have to do anything on this. Once we put the smallest in the first position, we have to do everything on this array starting from here. Once we put the second smallest over here, we always have to start from this part and do operation over here. The first and second number are always in the correct or got into its correct position. Now here the reverse is happening. Okay, here what is happening? Once you go to this entire array, you are putting the largest at the end. So this part is still unsorted. This part, right? Only the largest element got to its correct position. This part is still unsorted. When you put the second largest and the second last position, this part is still unsorted. Only the second largest went to over here. Right, second largest and largest are in its correct position, and the other remaining part of the array is not in its correct position. So they need sorting, right? Understood? Yes, no, clear? So now can we do something over here? Few things over here? Yes. So there are few things that we can do over here. So for example, we can do it n minus 1 minus I. What is this? So you can even run to this iterations, and if you run this, it would still be sorting the list. Now, why is it still sorting the list? Why minus I is still sorting C? So the first iteration, what is n minus 1 minus I? So we are going till n minus 1, which is fine. Like earlier we were going. In the second iteration, we are going till n minus 2. Why? This is still working because the last index would have the largest element. So you don't need to do anything on the last index. If you compare the second last and last, this operation is going to be false always because this is the largest number. Same goes for after the second iteration. If you compare these two elements, this is also going to be false because this is the second largest number. So this no number will replace this, no number can replace this. So these two numbers cannot be replaced. After third iteration, these three numbers cannot be replaced, right? So every iteration we can just decrease the j by 1. So we just need to first iteration will run till here. Second time we'll just run till here. Third time we'll just run till here, because these numbers are in its correct position. So the numbers that got into its correct position, we don't need to do anything with them, right? So you can just skip them into the next consecutive iterations. So that will save our few iterations in the loop. Okay, understood? Why is this working? N minus 1 minus I. Yes, no, yes, got it. Okay.
But for J, it's less seeing the iterations, but for I, it's going till N only.
So the total number of iterations will be N, right? That is the total number of iterations. That would be N. On J, we can reduce, right? So J, like in the J times we are reducing. So basically, for N numbers, we have to put them in the correct position. Let's say the worst scenario, if the like array sorted in descending order, and we have to make it ascending. So first iteration, every swap will satisfy. So we'll move, let's say this is our array, right? So we have this as 10, 9, 8, 7, 6, 5, and we have to basically swap it, sort it into the ascending order. So basically what we'll do is this will also satisfy, we'll swap it, then 10, 9 will also satisfy. We'll swap this, then we'll swap this, then we'll swap this. So every iteration would satisfy, right? So this would be also satisfying. This would also satisfy, and we'll swap it. So this came to its correct position. This array is not correct. So now we can skip this one. So next iteration, what we are doing in J time, we are skipping this. Number of, like, total number of times you have to run this, that still remains same, right? But in each iteration, we can just ignore this last number. And then after the next iteration, we'll ignore 9 as well. After the next iteration, we'll ignore 8 as well. And the remaining part will just apply that. Okay.
Basically, it won't go in swapping thing, but it check till last only for I iterations.
No, it won't even check, right? Because we have not running, we are not running the J loop. So I basically runs how many times we have to do this, right? So for how many times we have to go through, right? So for example, let's check what I is doing. So I loop is telling first iteration, right? So I loop is telling, let's say, number of iteration. So I is telling this is the first iteration, we go till here. Then I equals to 1, this is the second iteration, we go till here. I equals to 2, third iteration, we go till here. I equals to 3, fourth iteration, we go till just 3. I equals to 4, we go till here. I equals to 5, we go till here. I equals to 6, we just go till here. So there are, so 6, 7 numbers, right? So 4 and 3, total 7 times we are checking this. For the last iteration, it doesn't do anything, right? So if you put n minus 1 numbers into its correct position, last number is automatically in its correct position, right? So if you run it till n minus 1, that is also going to be fine. Similar to like what we did earlier, right? So if you are putting n minus 1 numbers into its correct position, last number is automatically in correct position. So you don't need to run this one, but remaining operations you need to run, right? So we are just ignoring the last part, which is in the correct position. So like similar to what we did over here. So we ignored the first part, which got its correct position. Here we are ignoring the last part from here. Okay. Now understood? Clear, everyone? Yes. Now, when it can be used, what's the usage of this? Bubble other than algo. If you want to find the second largest element, then we can use bubble other than other algo. Bubble would be fine if you want to find, like, so selection is can still do, right? Selection would do it in less number of swaps. I'll tell you what's the usage of this. First, tell me everyone understood this, right? Because the next thing you might fly over the head. Okay. So firstly, tell me everyone understood this thing. ये समझ आया? Okay. Acha. Tell me one thing. Now, if everyone understood this, will you ever be able to, in the middle of the sorting algorithm, okay, let's say this is our array, okay? So we have 10, 9, 1, 2, 3, 4, 5. Acha. Tell me after first swap, what would happen? So 9, 1, 2, 3, 4, 5, 10. Yes. After we went through this entire array for the first iteration. Yes. This would be the result. Everyone agrees? Anyone any doubts why this should be the result after first iteration? So after, when I equals to 0, we go through the J loop, and this is the state of the array. Now when I equals to 1, we go through this loop again, and this is the state of array. 1, 2, 3, 4, 5, 9, 10. Okay. Now, if on the third iteration, nothing swaps. On the fourth iteration, nothing swaps. On the fifth iteration, nothing swaps. No swaps are happening on these iterations. The array is like already sorted. So if you compare any one of them, this condition will never satisfy. Right? If j greater than a of j plus 1, a of j greater than j plus 1, j greater than j plus 1, none of the conditions satisfies. So you don't do any swaps or you don't do any swap operations over here. Now, okay. So we did this logic, right? We wrote we are actually sorting this, and then we are getting the sorting in the middle of some iterations. So let's say, and this can be very large array, right? This can be insanely large array. Let's say 10 to the power 5. Okay, 10 to the power 5, 10 to the power 6 size array, and only 2-3 elements were in out of order, and the remaining elements were correctly sorted. Now, do you need to actually run this operation for the entire array? No. Right, if you just run it for 2-3 times, you would get the sorted list, right? You don't need to run it for the like so many times. You should just run it for 2-3 times, you'll get the sorted list. Yes, correct. Okay, so now what you can do is, when can we stop the sorting in between? Is there any way to predict whether sorting can be stopped? We are not breaking the loop currently, but can we stop the sorting? So actually we can. So what we can do is, let's take a Boolean variable, let's call it as flag, which is equals to false. Okay, let's say flag is equals to true. Okay, it basically says whether we performed no swaps. Initially we did not perform any swaps. We are told that flag is true, that means we did not perform any swap. Right now, okay, let me mark this as no swap. Let's call it as no swap. Okay, so initially it is true. If we perform any swap, then we just mark this flag to false. Okay. Now at the end of this loop, if we will check if there is no swap, right? If we did not perform any swaps in this loop, if this is true, we can simply break. Right. So now let's say, for example, I equals to 0, we ran this entire loop and we performed a swap. So okay, we won't break. If I equals to 1, we performed any one swap, then we will not break. For I equals to 2, if we did not perform any swap, that means every element was there in order. If there was even one element not in its correct position, then we would have definitely performed the swap at least once. Right? If we are performing no swaps while traversing the array, right, by comparing any two consecutive numbers, then it is actually sorted. Right? You cannot get an unsorted array where you are performing no swaps. So if this is the array, then only you will not perform any swap. Right? You don't need to perform any swap. This condition will never satisfy. If you have even one element, let's say this is 8. So this condition will satisfy for these two numbers. So you'll perform one swap over here, and that might result in more consecutive swaps, but you will be performing one swap, right? So let's say this was 5, not 8, right? So you will perform at least one swap over here, right? You'll perform one swap and then it becomes sorted. Now in the next iteration, we won't perform any swap. And after the next iteration, we can say that since there was no swap that was performed, this array is sorted, right? So we can look for if there was any swap that was performed in this array. If there was no swaps that was actually performed in this array, we can say that this is, we don't need to run this. Okay, sorry, there was something that went over here. So now it's still working fine. Now, if the array is sorted, okay, now assume there are very high chance that the initial array might be sorted, okay, or there are very high chance that most of the numbers in the initial array are sorted. So what is selection sort doing? When selection sort, we are selecting numbers, we are going to every cell and we are comparing it. There is no way we can optimize it. It is going to run to n square. Even if every number is at its correct position, in order to validate, it will first pick the first number. Even let's say you give a sorted array to selection sort. See what happens. If you give a sorted array to selection sort, what it will do? It will pick one. It will go through the entire array. It will check. Is it in its correct position? Is there any number smaller than this? It will say, oh, this is in its correct position. This condition not satisfied. So it doesn't perform any swap. Now I will for here, it will again go through the entire array. I is over here, it will again go through the entire array. If I is over here, it will again go through the entire array. Right? But in selection sort, where will you break the loop? If this condition is not satisfied, will we break the loop? Tell me in this situation what's going to happen. 1, 10, 4, 3, 2, 1, 5. So this array is not sorted. You check for the first iteration. One is so you'll get I not equals to mn. Okay, you break the loop. This part never gets sorted. right? So you cannot break the loop if one of the element is its correct position, right? So one element can be in its correct position. For example, 3, let's say, is it in its correct position? Yes, 3 is in its correct position. 1, 1, 2. Right? So this 1, 1, 2, 3 is already in its correct position. We don't need to swap 3. So for 3, you will get, okay, it's in correct position. But does that mean this part after 3 is also sorted? No. Right? So here there is no way you can predict whether the array is sorted, right? You can check for the current number. We are not checking for the entire array, right? We don't know whether this part is sorted or not. We just are checking for one number, selecting it and checking whether it is in its correct position or not. But if the array is already sorted, or if there is any array sorted for majority of the numbers, bubble sort would work better, because the numbers that are not sorted will go to its correct position in each iteration. So every iteration it is putting one number into its correct position. Okay, so the largest into it, the last, or the second largest into the second last, and so on.
सर सिलेक्शन शॉट का और एक बार बताइए सर.
ठीक है, now think of this. ठीक है, ऐसे सोचो. चलो, how do I explain? Again, cards. Luckily we have few cards today. ठीक है, think of this. Okay, think through this. ठीक है, let's say this is the cards that we have. Okay, so 8. ठीक है, selection sort. What is happening in selection sort? What we are doing, just look. So we are picking 8 and we are telling we will compare 8 with all the numbers in the list. ठीक है, if 8 is in the correct position, then we'll not do anything, right? If I is not equals to mn, then we'll swap. If I is equals to mn, if 8 is the minimum number in the array, then we'll not do anything. So right now when we do the comparison, we'll find, oh, 2 is the smallest one, so this number is the smallest one, we need to swap it. So I guess which is this 2, or there is no 2, there is 5. Okay, we'll get 3. Yes, 3 is the smallest one. So 3 is the smallest one, we need to swap it with 8. Okay, so we will swap these two numbers. 8 would 3 would come over here, 8 would go over here. Now only 3 came to its correct position, but the remaining part of array is still unsorted. This part we are not sure of whether it is sorted or unsorted. Let's say at some position, right? Let's say 3 was already over here. Let's assume this is the initial array given. Now 3 is already at the correct position. Now we looked, is there any number smaller than 3? We did not find any number smaller than 3. 3 is already at its correct position. Now, do we need to swap 3? No. So this condition would not satisfy. I not equals to mn will not satisfy, because 3 is the minimum number. Now, this part of array, does it mean this part of array is sorted? No, this part of array can be unsorted. So basically you might get one number that can be in its correct position. It can also even come in the middle of the array, right? But that doesn't ensure the other numbers are in its correct position. So you might get 3 over here, which is in its correct position, but that doesn't ensure the right part of it is sorted. That might be unsorted, right? So you cannot put such checks over here, but in bubble sort you can do. So what in bubble sort we are checking for every 2 consecutive numbers, if there is any such number that is out of order, right? So for example, so what I'm telling, if there is no swap that happens over here, that means array is sorted, right? So if there is no swap, so for example, if this is the array, okay, so you don't even need a swap, because none of the conditions will satisfy. If you compare any 2 consecutive numbers, every number is in order and you don't need to do any swap, right? But even if there is one number, let's say 8 is over here, even if one number is out of order, this condition will satisfy for at least one time. Oh, yes or no? Check. So this element is out of order. Now this a of j is greater than j plus 1. This element is greater than j plus 1. So this condition would satisfy. But think of any scenario, right? Even if I have one number in the ascending sort which is not in its correct position, it will satisfy this condition that whatever is that index, let's say x, right? E of x, if it is not in the correct position, then it will satisfy this, that this is greater than a of x plus 1, right? Okay, understood? If you sort first 3 elements, yes, 3n is order n, right? 3n is order n. So bubble sort, we have a way to kill the sort in between. If after doing few like operation, after doing if after iterating to 2-3 times, we get the sorted list. So now let's say if you have an array such that you know that the array is almost sorted, there are only 2-3 elements out of order, right? So you don't know which 2-3 elements are out of order, right? So if you exactly know which 2-3 elements are out of order, you can do selection sort. You can select those 3 elements, put them into its correct position, right? So selection sort won't work in that scenario, but bubble sort will. right? If you just know 2-3 elements are out of order and all the other elements are in its correct position, no matter which 2-3 elements are out of order, it can be the first, last, you can have the entire array sorted. So let's say this is 9, 8, and you have this as, and let's say there is 1, 11 over here, there is 2 over here, there is 3 over here. Okay. So now, actually, if you do the first iteration, what is going to happen? Look, so there are 2-3 elements which are not in the order. Okay, so if you do the first iteration, 2 would come over here, 3 would come over here, 8, 9, 10, 11. Just check. 11 getting swapped with it. Next, 11 come over here. Second iteration, you would actually swap this 2 and 3. This is not in order. You'll get this. Now see, the entire array got sorted in the second iteration itself. Right now, in the third iteration, you'll get no swap. No swap will be true. This would be true, and you won't mark it. We won't mark it false because there is no such element which would satisfy this condition. So it'll break. So we just broke the loop in 2n. We did not run it till n square, right? So in the case, just if 2-3 elements are out of order, and that can be any 2-3 element present at any random index. So it's best to use bubble sort instead of selection sort, right? Selection sort is has another use case. If you have a very long list and you want to just sort it partially, or only 3 elements, 5 elements in that list, in the entire list you just want to sort 3 elements or 5 elements, selection sort is best. A real example is Google search, right? You might have hundreds of pages getting thousands of links, but if you apply a sort on based on time, let's say, so you just want to sort it on the first page, don't want to apply sorting on the remaining page. So you can just apply a partial sort, which will be on the first page. So the first 10 results will be the sorted, which will be the, like, in the descending order of time. The remaining part will be random. If you go to the second page, we'll sort the numbers from 11 to 20. Okay, we'll sort the numbers from 11. If you go to third page, we'll sort from 21 to 30. But we'll apply partial sort every time, not the complete sort at once, because you might not be viewing those pages. So we optimize it, right? Here, if you already know that the data is sorted partially, there are few elements which are random. So you can apply bubble sort. That will give you the best complexity. It will automatically figure out how many iterations to run and where to skip. Okay. Let's talk about now the complexity, since this is there. So what's the best, worst, and average case complexity of this? Yeah. Yes.
Sir, if we get no swap true in between in bubble sort, remaining elements haven't been sorted in ascending order.
If we have
no swap will become true. Has become true in between the between sorting, and the remaining elements hasn't been sorted.
It can never happen. It can never happen. If there is any element which is not in the sorted order, right? That's what I'm telling, right? Try to write an array and think where this condition will be satisfied. If there is this condition will never satisfy if the array is so this condition will satisfy if the array is not sorted. If any one number in the array is not sorted, now this would satisfy. Let's say this. Let's say you're telling that, let's say, even if there cannot be a situation like that, right? So for example, if this is 1, this is 3, or let's say this remaining part is 6, 8. Okay, so this would satisfy, right? You cannot. How will this get skipped, right? This cannot get skipped. So this would satisfy. So this condition will satisfy until you get the sorted array. So for example, consider this, right? So what we are doing is we are comparing NA to consecutive array. Now, when you will get A of j is greater than j plus 1 is false, if this array is sorted. If this array is unsorted, you will get this as true. Right? ये true होगा ही होगा. किसी एक element के लिए तो होगा, definitely होगा, right? You cannot give me one example. Think of any one example. You will not get any examples. Okay, when this condition will not be true and you have unsorted number in the list. Okay,
Hello,
it
sir.
is not possible.
Hello, sir.
Yeah.
सर अगर मान लीजिए से एरे में 100 एलिमेंट है और वो ऑलमोस्ट शॉर्टेड है 2-3 एलिमेंट के अलावा, उस केस में सर बबल सॉर्ट यूज करेंगे हम? हाँ,
उस केस में बबल सॉर्ट यूज करेंगे, राइट? अगर हमें बेसिक आइडिया कि मान लो कि हमें पता है कि सॉर्टेड है ऑलमोस्ट, बट कुछ एलिमेंट्स है जो सॉर्टेड नहीं है, राइट? तो हम बबल सॉर्ट यूज कर लेंगे. तो बबल सॉर्ट क्या करेगा, 2-3 इटरेशंस करके उन 2-3 एलिमेंट्स को अपने करेक्ट पोजीशन पे पुट कर देगा और रिमेनिंग एलिमेंट्स को करेक्ट पोजीशंस पे थे, राइट? तो हमारा एरे सॉर्ट हो जाएगा और वो हमें पता भी नहीं करना है कि कितने इटरेशन. हमें रफली भी अगर आइडिया रहेगा कि 3 4 5 एलिमेंट से अनसॉर्टेड, सो वो ऑटोमेटिकली उतने बार रन कर जाएगा, राइट। हमें वो नंबर नहीं बताना कि कितने बार रन करना है। जब स्वैप नहीं होगा, जब उसे पता चल जाएगी एरे सॉर्ट हो चुका है, we don't have any more swaps, it will automatically terminate. Okay, so let's see the best, worst and average case complexities. So here in the best case, like if you have the sorted array, so let's consider the three cases: best case, which is worst case, and what is average case. So best case is if the array is already sorted. So within how much time will it tell you the array is sorted? So we don't have any breaks in between. No matter if the array is sorted, will still run for this will run for n-1 time. This is anyways going to run till order n, right? In the best case as well, this is order n square. See why it is n square? We are not breaking the loop, right? Even if it is sorted, we will end up like for every I equals to 0, we are running from 0 to 1 to n. Every I equals to 1, we are running from 2 to n. I equals to 2, we are running from 2 to n, so on, right? In the worst case, when the array is sorted in descending order, then we'll swap every time, right? Every time swap condition will also satisfy. We'll do this. So that scenario as well, this is also n square. See, if we have not put any breaks in between, so every time we'll go till n square. In average case as well, if the numbers are random, right? So we'll get n square. In all the three cases, it is n square, but it is very good if we have to apply partial sorting. Okay, partial sorting may, if you have to apply sorting on first 5 or just you have to sort 5 numbers out of the entire array, 10 numbers out of the entire array, selection sorts works fine. It is just like finding first minimum, second minimum, third and minimum, fourth minimum. I'm seeing the questions.
So what is calling partial sort, sir?
Partial sort means, let's say you have 1000 numbers, but you just want to apply sorting on the 10 numbers, right? You want to get 10 smallest number or 10 largest number, but not like put entire array into sorted list. Okay. Did I miss any questions? If we sort 3 elements by the selection sort of complicated. Yes, that would be order n if we just sort 3 numbers in the condition complexity sort with this. If the array is sorted, then the complexity of bubble sort is lesser. Okay, so I'll talk about best worst case complexity. If log inside the condition in selection short line 2 5 6. No, it won't work, right? So see, that's what I'm trying to tell. See, even if you put a flag in selection sort, there is nowhere to put a flag. You see this, right? So for example, let's consider 3 8 13 2 1 5 6. Let's say you check for 1. Okay, so this condition will never satisfy. This is never going to satisfy because 1 is the minimum number. You are trying to find out the minimum in this array. Okay, this condition will never satisfy. Your minimum will still be pointing to I. Even if you put a flag, that flag will be false. You won't need the swap. But does it mean if I'm not swapping 1 is if 1 is in the correct position, that means the array is sorted? No, this part can be unsorted. We have no idea about this, right? So here in each iteration, we are trying to find out the smallest number, put it into its correct position. Now, if that number is in its correct position, we don't know about other numbers, right? उसके बारे में तो हम नहीं बोल सकते कि वो correct है या नहीं, right? Okay, so that's one problem over here, right? So we cannot do it in best, worst, average. All of the cases, it's going to be n square. Now look at this bubble sort. Okay, this we call as modified bubble sort. This is not the initial one where we have swaps, but this I would say prefer writing this because this is a better one, right? In interviews, I would say write this bubble sort, not the like initial one, right? Write it using checking this swaps. Okay. Now let's check the best, worst, and average case. Best case. For the best case complexity, it is big of order n. If the array is already sorted, you will be able to get in one single traversal whether the array is sorted or not, and you will break it, right? You have a break, right? Now in worst case, if the array is sorted in descending and you want to sort it in ascending, so that is n square. In average case, if array's elements are random, then you might still run up to n square times, right? So in average case also, this is big of n square. Understood? So these two sorting algorithms, where to use what? Okay, clear? Got it? Any doubts? Move on, sir. It's my 0 to n and j. Then sir, I greater than j. Oh, got it. I guess Mohammed, you're talking about the insertion shot. That's what is the next shot. Okay, if these two are clear, okay, then let's do a quick exercise. Okay, how many of you have access of paper? Can you get a sheet of paper for me, or a deck of cards if you have that? That would be super. If you can get a deck of cards or any sheet of paper, right? If you can have any sheet of paper, that would also be fine. If you don't have a deck of cards, paper, take a paper box, right? Go get a paper for all of us. Get a paper for yourself. Okay. Got the paper? Okay, last time I did not have this card, so I was looking for paper in the session and I was not able to find paper. So I thought, okay, my everything is there in text, so I don't even use papers nowadays a lot. Okay, got the paper? Fine. See, everyone, please do it. Right, this is for understanding. You won't be able to understand this. So please do this exercise. Right, in case you are wondering what we are trying to do, just get a paper. Okay. Now fold it up and tear it into multiple pages. So basically, if you have a paper, just fold it, tear it. So get like six, seven this small size paper, right? That would work fine. Similar to like just try to create small papers out of it, 6, 7 sizes. Okay, try to just fold it, tear it, fold it, tear it, fold it, tear it. Get 6, 8 papers, right? Small size paper, squares, rectangles, works. Okay. Got this? Okay. Done? No? Okay. I'll give you a minute. Tear it up. I can tear it. If you have something to cut it, you can cut it, but you can tear it, right? That should be fine. Tearing won't be that much problem. Okay, got it. Now, 8 is fine. 8 is fine. Any 6, 8, that should be fine. Okay. Now write 8 random numbers into this paper. Write 8 random numbers. Okay. 8 random numbers into these papers. 2, 8, 5, 7. If you have duplicates, that's also going to be fine. No, if you even have duplicates, that's not a problem. Write 8 random numbers. Okay. Just don't write the same number in every paper. Write 8 random numbers. Okay. Now, okay. Let me know when everyone is ready. Single digit, multiple digits, anything is fine. Just numbers, right? 12, 15, if you want to write, right? Whatever number you want to write. Okay. Done. Let me know once if you are done. All of you are ready. We'll do a. Okay. For those who are ready, you can put a done so that I can know most of you are ready with this. Yes, I'll wait. Done. Okay. Acha. Now you all have to just put the papers in the random fashion in your it should be random. You can keep the papers random numbers. So it should look something like this. If you whatever numbers you have written, it can be your different numbers, but you can have this in the random order. Okay, just that your number should be in random. It should not be already sorted. Okay. Okay. Done, everyone. Okay. Now, if done, let's do one quick exercise. Okay. If all of you are done with this, let's do a quick competition of who can sort this papers, who can sort this list as quickly as possible. Okay. So I'll also do my sorting. You can apply sorting on your list and try to do it as quickly as possible. So we'll show each other the list of final sorted list. Okay. Okay. Your time starts now. Apply the sorting as quickly as possible. You need to sort the list of papers as quickly as you can. Okay. Done. Okay. How many should sorted it? Done. Acha. Now, okay, I can tell you, I can for sure tell you, you did not apply selection sort, you did not apply bubble sort, right? None of you applied selection or bubble sort. Did anyone apply selection or bubble sort? Now look, just think a minute before, did you apply selection or bubble sort? Okay, someone applied bubble, okay. It might look like bubble, but you actually did not apply bubble, okay. I'll tell you what did you all do. Okay, I'll tell you what you all do. And this is the default sorting algorithm that's there in our brain, right? So you all would have applied this thing. Okay, it looks like somewhat like selection, somewhat like bubble, but it is not that. See, let me show you what you all would have actually done. Okay, so let's say let's take this one. So this is like, let's say the random list of this is the random list of cards that we have. Okay, let me just spread it first. Spread this card in the reverse way. Okay, so let's say this is the random list of cards that we have, and this is like the start. Let's assume this is the start of the array, and we go all the way to end. Okay, what you did was what your mind did. Actually, you did it in this way. So you checked 3, you checked 5. Okay, 5 is correct. Then the next number you saw was 6. Okay, 6 is correct. Then the next number you saw was 8. Okay, 8 is correct. Then the next number you saw was 7. So oh, 7 is not correct. Let me quickly put it into its correct position. So you put 7 over here, 8. Okay, 7 over 8, and that's it in its correct position. Next you saw, okay, what's the next number? You saw 9. Okay, 9 is it in correct position? Let's not do. You saw 4. Oh, 4 is not in its correct position. Where should 4 be? 4 should be over here. Right? Let me put 4 over here. Right? So 4 between 3 and 5. Right? So now 4 is in its correct position. 10 and 8. So 10 is in its correct position. 8 is not in its correct position. Where should 8 go? Just before 9. Right? So let's put 8 before 9, and we are done. Did you all do this? So you just ran through it. You tried to figure out which number is not in its correct position, and you just immediately put it into its correct position, right? You inserted the number into its correct position. You did not like do selection. You did not calculate it. So selection requires some calculation, right? So for example, in selection, you would have picked 3. You would have traversed the entire array. You would have found out whether 3 is it in its correct position. 4, you will traverse the entire array, find out whether 4 is it in its correct position. It requires calculation. You do not do that. It looks like bubble that if you see something out in order, you actually swap it, but you did not swap just with it. So for example, when you saw 10 and 8, let's say you saw something over here, you did not do this operation, right? So for example, let's say this 9 is over here, so you did not swap 9 with 6, you did not swap then 9 with 7 and so on. You just picked 9 and you found out, okay, where should it be in its correct sorted order, right? Where should 6 be in its correct sorted order, and you just put it into its correct sorted place, right? Let me draw this, right? Let me draw this instead of card. Let me do this. Okay, see what you all did was, so let's say you have a list of numbers 2, 5, 1, 3, 4, 8, 3. Okay, let's say this is a list of numbers. So what you did was you started from here, right? You checked, okay, 2 is it in its correct position. Let's not worry about 2. 5 is it in its correct position. You saw 1. As soon as you saw 1, what you did was, oh, 1 is not in its correct position. Where should 1 be? 1 should be over here. So 1, 2, 5. Okay. And this remaining part is as it is. You did not touch this part. You have not revisited this part till now. Next, you saw 3. Oh, you immediately figured out, okay, 3 should not be here. Where should 3 be? Between 2 and 5, right? So you immediately put 3 over here. And this part is as it is. Next, you saw 4. Oh, 4 is again not in its correct position. Let's put 4 into its correct position. You put 4 over here, and remaining part you did not touch. You saw 8. 8 is in its correct position right now. 3 is not in its correct position. Where should 3 be? In between this 3 and 4. So we put 3 over here, and we got this. Did you all do this? Tell me honestly, how many of you did this? So if you ever get a timeout constant that you have to sort, you have to apply sort, your brain doesn't think anything. It will just figure out whether the number is in its correct position. If not, it will put it into its correct position, right? You can throw it out of the balcony, right? Just that it gets ignored. Inserting an element at the middle of the beginning of shifting the other elements to the right. Yes. Okay. Acha, tell me how many of you got this? How many of you understood what this insertion sort is? Yes, this is insertion sort. Picking any number which is not in its correct position and then putting that number into its correct position is known as insertion sort. Inserting the number into its correct position, right? It looks like bubble, but you did not apply bubble. You did not swap. You did not perform multiple swaps. If you notice, you would have performed only one swap where you would have put it into its correct position, right? Yes. Now there is largest, smallest equal. Right. Current element we pick the current element, we just put it into its correct position. If you just keep the deck of cards without spreading it, right, you would essentially do it, try to now do it multiple times. You would automatically apply this sort. You don't need to know the logic. If you ever, like if I ever tell you to apply doing sorting, you will, sure, our brains are programmed to do insertion sort. Okay. Because this is the easiest one where like if we have something physical in hand, let's say cards or a piece of paper which we have to sort, our brain would automatically put this into like sort it in this particular way, right? If you feel like if you want to get more practical application of this, take more papers. Okay, I know I'm telling you to cut papers, but that will help you understand. Spread it on spread it on like the floor and have more papers, let's say 10, 15, 20, just put it in the random order. Okay, not try to apply sorting. You would essentially do this, right? You won't be swapping. You might do who got this one name? I don't know, right? I just by looking at all the sorting algorithms, I realized that brain automatically applies this one. Okay, so I figured this out. So I always do this exercise, and I'm also surprised that most of the students apply insertion sort. Right, everyone applies insertion sort even without knowing. Right, I never tell everyone. A paper ka kya kare? Use it to see it again. Right, use to see all the sorting algorithms. Right, so now there is a usage of paper. Don't waste it. Don't throw it right away. After the class, right, when you go through all these algorithms, use that paper to see how selection sort is working, how bubble sort is working, and how insertion sort is working, right? And that will easily help you to distinguish between the three, since you are seeing it physically instead of just seeing the code. Okay, understood? Now there are few problems, right? Implementation wise, it is not as easy as selection or bubble. Okay, implementation wise, it is difficult. Why? See, so it is difficult because of one single thing of array, because array is immutable. So when I told you to do this operation, what you did was, okay, let's say this is your array. So you started with 2, okay, 2 is in correct position, 6 is in its correct position, you saw 4. Oh, 4 is not in its correct position, let's put 4 into its correct position. Now, what does it require? You have to delete 4 from here, basically you remove the card from here. We have to insert something over here. So, but when you were doing it using physical papers, we are able to perform these two operations easily. Delete and insert, right? But now are you allowed to perform a delete and insert operation? No, right? You're not allowed to perform a delete and insert operation, right? We cannot delete, we cannot insert. How can we do it then? Agar delete bhi nahi kar sakte, agar insert bhi nahi kar sakte, then how will we do this? So array doesn't allow delete, array doesn't allow insert. How can we do this? Shifting, yes. So we can shift every time we can shift it to the right. So we can figure out every time we'll shift these numbers to the right, we'll find the correct position and then we'll insert 4. So in this case, we'll shift just 6 to the right. Okay. 4 will store in something else and we can put 4 into its correct position. Next iteration, we got 2. So what we'll do is we'll shift 6 to here, we'll shift 4 to here, and then we'll find out, okay, 2 is in its correct position, we'll place 2 over here, this 2 is already over here, 1 and 3. Next rotation will find out 1, so we'll shift everything to our side. 6 will go over here, 4 will go over here, 4 will go over, sorry, 2 will go over here, 2 will go over here. We have a 1. Now 1 will place it into its correct position, which is this. Okay, 3 will be over. Last time 3 is over here, so we'll shift everything to the right. 6 will go over here, 4 will go over here, 2 will go over, sorry, 2 will not shift, right, 2 shift. Okay, 4 will go over here, 3 is now in its correct position, so 3 will come over here, 2 and 2 remains over here, 1 remains over here. Okay, so now we can get there by shifting every element that should be after it to the right, and inserting that element into that backend spot that we created by shifting every element to the right side. Understood? Yes. Okay. Now, like insertion sort has a lot of usage, right? This is a very good sorting algorithm. In case in case there is already sorted, in case you want to apply sorting on any random, so this has the minimum number of swaps, right? We don't we are shifting it, so that is like kind of swap, but okay, we're not doing too much swaps. Okay. Too many shiftings are required. Yes. Okay. So I'll give you a quick break. We are already on the dinner time. Oh, why did I stop this here? Okay. So I'll give you a quick break. Come back. We'll write the logic. Okay. Now, in the meanwhile, if you want, you can play with those cards that you have created. Okay, to understand the selection and bubble sort. Okay. The garbage collection. Array sort has a different implementation, right? It is using merge and insertion sort. So I'll talk about that. It uses insertion sort. Yes, it uses insertion sort. Okay. Quickly have a dinner, come back, we'll discuss this. Okay. Hello everyone. Welcome back. I hope you all have done your dinner. Okay, so let's continue. Okay, so we understood about selection sort. We understood about bubble sort, right? So in selection sort, what we are doing is we are picking one element, right? And we are assuming that this is smallest. If not, then we are finding out the smallest one and putting it into its correct position, right? Then second iteration, finding out the second smallest, putting it into its correct position. Third iteration, finding out the third smallest, putting into its correct position. Okay. In bubble, what we are doing is we are comparing every two consecutive numbers. If they are not in order, we are swapping them. And we'll keep on doing this, right? For like one traversal of array, and we'll do it for n traversals of array or n-1 traversals, right? Here. So what this will do is first traversal, it will put the largest at the end, second traversal, second largest at the second last, third traversal, third largest at the third last, and so on, right? So it will put all these elements. Now finally we'll get the sorted array. Now in insertion, what did we know that? In insertion, what we can do is instead of doing all this, what we can figure out is we'll start by assuming that this was single size array is sorted. Then we'll expand this, we'll see, okay, 6 is also sorted. One is not into its correct position. So we'll put 1 into its correct position. Now how we can put 1 into its correct position? We'll need to swap this. We'll need to put 1 over here and we'll need to shift everything towards right? Now, what we need to do is we need to do one single traversal of array to check if every element is into its correct position. If not, then we'll insert it into its correct position. Okay. So let's say we start with 0 and we'll go till n, so that will run for every number in the array. We'll check whether it is in its correct position. If not, then we'll insert it into its correct position. Okay. Now, how can we insert it? So from where do we want to start the comparison? We want to start the comparison from j minus 1. So j equals to I minus 1. So for example, let's say we are at any index. Let's pick this one. Let's pick 1. Let's pick 1, which is not into its correct position. So what we'll do is we'll start with 6. We'll compare, is it into its correct position? If not, then we'll swap this. Okay. We'll swap this. Which is the number with which we have to compare? We'll compare with the current number. So what is the current number? Let's call it as the current number, which is a of I. So we have to put a of I, that is the current number, into its correct position. Until when we'll keep on shifting? Until we find the correct position for this current number. So what we can do is we can run a loop until, let's say, if j is greater than equals to 0, and until basically we don't reach the end of this, right? And until the current number is less than a of j. Right? If the current number is less than a of j, so for example, this is a of j, right? This is a of j. Current number is 1. If this is less than this, then we'll shift it to the right. So basically, a of j plus 1 is equals to a of j. And we'll just do j minus 1. See what we are doing? So we are shifting this, right? See here, we are not swapping, we are shifting. Okay, we are shifting. Okay. For 0, it would become minus 1. That's fine. This condition is not going to satisfy. We're not going to run it. See. So let's assume for this one. Let's assume for this number. What we have done is, let's assume I is over here. So I is equal to 0, 1, 2. I is at 2, which is out of order. Right? This is the first number which is out of order. We need to do like swaps over here. Right? Now what we can do is we can check whether so what we'll do is we'll check whether this is lesser than any previous numbers. So we'll check. So current number is a of 2, which is 1. Okay, current number is 1. What is j? I minus 1. So j is equals to I minus 1, which is 1. Okay, so j is equals to 1. Current number is 1. Okay, now we check whether j is greater than equals to 0. Whether 1 is greater than equals to 0. Yes, it is greater than equals to 0. Okay, now just a second, yeah. And whether the current number is less than, whether this number is less than the previous number, whether it is less than 6. Yes, it is less than 6. This number is less than 6, right? So what we need to do is we need to shift this number over here, right? Because if this number is greater than 6, we don't have to do this. Was 7, 8, we don't have to do this. Condition would be false. We don't have to do anything. But since this is less than 6, we have to shift 6. So what we did is j plus 1 is equal to j. So j was over here. So j plus 1 is this. This is equal to 6. Now I would say, sir, this number got overwritten, right? We lost 1. Okay, 1 is right now not present even in array, but we have a variable that is storing this number, which is correct. Okay. We decrease j became j minus minus, so j became 0. Okay. Next iteration we checked, is j greater than equal to 0? Yes. 0 is greater than equals to 0. J is still not terminated, and A of current is less than J. Is A of current, what is A of, current is 1, is current less than A of J? J is over here, J is 0, which is 2. Yes, current is less than 2, so this number should also shift to the right, right? So we checked, okay, this number should also shift to the right, we shifted 2 over here. Okay, we shifted 2 over here. Now this is 2, this is 6. We decreased J, J became -1. Now is J greater than equals to 0? No, J became -1. So that means we reached the end of the array. Now where this number should be in the index J plus 1. Wherever we have ended this loop, this number should be in the index of J plus 1, and we should put current over here. That's it. So now if we put current over here, what is going to happen? J is -1, so -1 plus 1, which is 0. At index 0, we are putting current, which is 1. So at index 0, we are putting 1. So this changes to 1, 2, 6. Which is fine. We inserted 1 into its correct position, and we shifted the remaining 2 numbers by 1, right? Let me write it over like this. So what we did was, so this changed, 1 came over here, 2 and 6 came over here. How you got the idea of what we are doing? So we are swapping. This is like the implementation is little bit confusing for the first go, but it's it's the same logic that we discussed, right? We are implementing it. So what we are doing is, see, till when you need to swap, if A of J is greater than current, if until you find a number that is smaller than this. Let's say this is the array. Let's say this is the array. Let's take this bigger array. Okay. Let's say you perform this swap. This array became 1, 2, 6. 1 came over here. Okay, let's take a little bit larger size array. Achha. Tell me if you take 3, till when you have to shift. Till when? Tell me the condition when you want to shift. Forget about this logic that I've written. Till when you want to perform the shift, and then you can say finally I got the correct position for 3. Until the numbers are greater than 3.
The
right?
previous element are greater than 3.
So if the numbers are greater than 3, you keep on shifting. If there is any number that becomes smaller than 3, you stop there. Right? I don't have to shift anymore. If the number is greater than 3, you keep on shifting. Right? Okay. So now what we are doing over here is, so see, let's say this is the array and we have 3. So we have 3 over here, and let's say I is pointing to this index. Okay. Just look what is going to happen. Why this is lagging? The video is also freezing. Okay, think. So let's say 0, 1, 2, 3, 4. So I is at index 4. Current is having the value 3. Okay. And A of J is equals to I minus 1. J is at index 3. Now see, J starts from here. Current is over here. Current is storing this value. Right? Current is storing the value, not the index. Right? So even if this value gets overwritten, current has the value. So what we want to do is we want to compare 3 with every number. So we compared 3 with 10. And we told, oh, 10 is greater than 3, right? A of J is greater than current. So 10 is greater than 3, right? 10 is greater than 3. So what we can do is we can simply put 10 over here. We are not swapping. We're just putting 10 over here. We're not swapping it. Okay. So after like putting 10 over here, it looks like this. 10 is over here. This is not swap, right? And J minus minus, J moves to its 1 index before. Now when J comes over here, I'm comparing 3 with current with 6. Is 6 greater than current? Yes, 6 is also greater than current. So we move 6 over here. Okay. Next iteration, we compare. Okay, so J again decreases. So J decreased to 2, J decreased to 1. So J came over here. We compared A of J with 3. Is A of J greater? Now is A of J greater? Is this greater? No. If this is not greater, that means the number should be inserted right after this. राइट इसके जस्ट बाद इंसर्ट होगा जब भी हमें उससे एक छोटा एलिमेंट मिलेगा अभी तक तो ग्रेटर मिल रहा था till now we were getting greater we were shifting it but now first time we got a number which is smaller so now the current number should be inserted right after it so this condition will not satisfy right 2 greater than 3 this won't satisfy right 2 greater than 3 this won't satisfy so we break we come out of the loop j plus 1 equals to current why we have inserted in j plus 1 because our loop will only break either j becomes -1 in this situation we have to insert at 0 And either the number at j, is less than the current number, right? So let's say 2 is less than, 2 is less than, this condition was false, right? So this number is less than the current number. So the number should be inserted after it, right? So whatever index j is, so we should insert it right after it, which is j plus 1. In both the cases, we have to insert it in j plus 1. So that's why j plus 1 is equals to current. Understood? Yes, no. Now it looks a little bit easy. Huh. Equal mein, this is like equal mein we are not going. So if there are multiple, like if there are 3s over here, we'll not swap 3s, right? It will just insert it right after. Right? यहाँ पे अगर एक और 3 होता, it would not swap it. So it will not shift 3. It will just insert right after 3. Because if you shift 3 and just put it at the first 3 or the last 3, doesn't matter, right? In sorting order, that is always fine. That so if there are multiple 3s, and you got a 3, so you don't need to insert it over here. Even if you insert it over here, that's fine, right? That is the correct sorting order. If you want to insert it at the start, you just can put equal to, but that will not cause any difference in sorting. Okay, understood? Let me do a quick dry run. Okay, let's do a quick dry run. Let me just first paste this. See, we are seeing the sorted list finally. Okay. Let's say index 1 by 3 over. Okay. And let's take a single 1 over here as a calculator. Okay. Okay. See, it's index 1. Okay. Let's take this right now. Okay. Let's see, right? I know this logic is confusing as compared to the other sorting ones. Okay. Let's look at over here. See, just let's do a quick dry run. Okay. Listen to this very carefully. You will be easily able to get this. So we started with I equals to 0. See, our main goal is that we have to figure out whether this number is in its correct position. If yes, then fine. If not, then we'll shift elements towards right and insert it into its correct position. Okay. So for I equals to 0, we started with j equals to I minus 1. So j would be minus 1. We found out a of I. So current is equals to a of 0, which is 3. Okay. We checked, is j greater than 0? No. J is greater than 0? No. This condition is false. This loop doesn't run. So we do a of j plus 1 is equals to current. So a of j plus 1 is a of 0 is equals to 3. Which is fine. We basically put the same number into its same position. We did not do any swap, any reassignment, or any shifting, anything. We just put the current number into its same position, right? Into its original position. Okay. No changes as such. Okay. So if this loop never runs, right, for any reason, we'll just put the number into its same position. Okay. Now let's look for what is going to happen for I equals to 1. So when I is equals to 1, look at here. When I equals to 1, j is 0. Current is 2. Okay. Current is a of I, which is 2. Now we'll check, is j greater than equals to 0? Yes. Is current less than a of j? Or let me write it in a different way, right? Think it like this, not much. I guess this is confusing. A of j is greater than current. Same thing, right? Either you check that or you check it in this way. So what we are checking, if a of j is greater than current, if a of j to previous number, right? This previous number, is it greater than current? Is 3 greater than 2? Yes, it is greater than 2. So we enter inside this and we just shift this. So we put 3 over here. 3 comes to here, right? And 2, okay, 3 comes to here and we change j to j minus 1. That's it. J minus 1 is j becomes minus 1. 3 shifts its value to the right. Next iteration, j is greater than 0. No, j is not greater than 0. J became minus 1. So we come to this particular place and we put j, a of j plus 1 equals to current. What is a of j plus 1? 0. Right? When j becomes minus 1, it is 0. So that means this is the smallest number till now. So we put it at the start. We'll put it 2 over here. Understood what is happening for 2? So we'll put 2 at the start index. So every time you find out the smallest number, right? Next time you find out 1, since 1 is smallest, we'll end up comparing with all the numbers, shifting everything. J becomes minus 1, we'll insert 1 at the index 0. Okay. So every time we find the smallest number, at the end we'll find out 0. 0 is the smallest. So we'll end up shifting everything towards right, and we'll insert 0 to the very first cell, which is j will become -1, and we'll insert 0 to the 0th index. Understood? Yes, no? Okay. Achha. So after this, our array state would be something like this, right? So 2 would go to here and 3 would be here. Okay. Now look at this value, what we are going to do for here. So when I becomes 2, let me use this. So now when I becomes 2, j is I minus 1, so j is 1. Okay. Current is a of I, so current is 6. Okay. We compare, is j greater than 0? Yes, j is greater than equal to 0. And is a of j is 1 greater than current? Is 1 greater than 6? No. Sorry. A of j is, sorry, it's not 1. It's 3. A of j is 3. A of 1, is 3 greater than 6? No, 3 is not greater than 6. That means 6 is greater. If 3 is not greater than 6, like that means 3 is smaller, and all the other elements towards its left are smaller than 3. Because till now this is the sorted list that we have created. So all the elements towards its left are smaller than 3, and 6 is greater than 3. That means 6 is in its correct position, right? We don't need to shift anything. We don't need to insert 6 anywhere. 6 is already in its correct position, right? So we don't enter inside this loop. Okay, we just come to this statement. What we are doing in this statement, a of j plus 1, which is a of 2, is equals to current. A of 2 is equals to 6. Basically, we put 6 into its same position, right? Because this is the correct position of 6. It doesn't need any movement, any shifts, and 6 can, so that 6 can be inserted. 6 is already in its correct position. Okay, understood? Okay, so now these 3 numbers got sorted. Okay, and next iteration, so every time you see a number that is already sorted, right now whatever array we are considering, so here you can see the, if you did not get the idea till now, so we are considering the array starting from one size, we increased it to 2, now we increased it to 3, now we are going to the 4th element. Now what we want to do is we want to insert 4 into the correct position if this is the entire array, right? So after every iteration, right, after the second, third, or fourth, you'll find out the first, after first iteration, you'll find out one array of sorted size, 2 array of sorted size, 3 size sorted array, 4 size sorted array. So now when we go to the index 3, which is the 4th element, we do j equals to I minus 1, which is 2, current is equals to 1. Now what we do, and we'll check, is j greater than equals to 0? Yes. And is a of j is 6 greater than equals to 1? Yes, 6 is greater than 1. So we need to shift 6. So shift will be shifted over here. J plus 1 is equals to j. That is a of 3 is equals to a of 2. J will come over here. Now we do j minus 1. J changes its value to 1. Then we again check. Is 3 greater than 1? 3 is greater than 1. Yes, 3 is also greater. That means we cannot insert 1 after it. We need to insert 1 before it. So let's shift 3. So it should be shifted over here. Next iteration, j changes its value to 0. Now we check, is 2 greater than 1? Yes, 2 is also greater than 1. So it cannot be inserted after 2. So you have to shift 2. So 2 will be shifted over here, right? Now we shifted every element and j will become -1. Now since j became -1, this condition is satisfied, we come out. So when does j become -1? So after, in the current iteration, if you find any number which is smallest till now, right? If whatever number we have got, this number is smallest. 1 was the smallest. So now we got 1. So what we'll do with 1 is we'll try to put it in the correct position, which is start with that. So j became -1. So we are putting it at j plus 1. So we are putting it a of 0 is equals to current, which is 4. So we put 1 over here. So now it became 1, 2, 3, 6, which is the sorted order. Earlier we had a 3 size sorted array. Now after running it for one more iteration, we got a sorted array of 4 size. Now are you seeing what is happening? We put 1 into its correct position, which is the sorted array, right? So it will look like 1, 2, 3, 6. So after this swap, so this all will shift towards right and 1 will insert. Now again 10, since it is in its correct position, we'll find out j minus 1, j equals to I minus 1. this will not, so is 6 greater than 10? No, 6 is not greater than 10. This condition doesn't satisfy. We don't run this loop and we just insert 10 into its own position, right over here. 10 doesn't get anything, nothing got shifted because this condition never satisfied, right? Now for 3, look at what we are going to do for 3. For last, let me do it for once more so you understand this. For I equals to 4, the value is 10. We don't do anything, right? Check for I equals to 4, j is 3, current is equals to 10. So for 3 is greater than 0, that's fine. But this condition, right? A of j is 6, right? So I is pointing over here. Is 6 greater than 10? No, this is not greater. That means 10 is already in its correct position. It is greater than the previous number, which is fine. It should be greater than its previous number. If it is, then it is already in the sorted order. If it is not greater than its previous number, that means, and the previous numbers are in sorted, that means this is not incorrect. We will shift numbers. Okay. But since this is correct, we won't do anything. We'll do just j plus 1, which is index 4. We are putting current, which is essentially not doing anything. Okay. Now, when we get to 3, see over here, what is going to happen? Now, this is the last iteration, right? Look at this very carefully. If you did not get it till now, you will be able to understand at least from this one. So I is 5, j is equals to 4, right? J is equals to 4, current is equals to 3. See, where I is over here, current j is over here, and we'll compare. Is 10 greater than 3? So j is greater than 0, that is fine. Is 10 greater than 3? Yes. Then 3, this is not the correct position for 3. 10 should get shifted. So 10 will shift over here. J plus 1 is equals to j minus 1. J becomes 3. We check. Is 6 greater than 3? Yes, 6 is also greater than 3. Then it should again shift. 6 should not be here. 6 should shift to here. Okay. J changes to 2. Yes. Okay. And this happens. Next iteration, A of 2. Is 3 greater than 3? No, this is false. 3 greater than 3 is not true. This is false. That means the current number should be inserted right after this. So right after this, at index j plus 1, we insert 3. So 3 would come over here. Now see, 3 is over here. Next number is 3. 6 goes shifted to here. 10 shifted to here. And this array till here got sorted. Understood? So basically, after every iteration, we are picking one number, putting it into its correct position by shifting all the other numbers towards right. Okay. I know this is like one of the most tricky, easiest concept to understand by looking at it. All the sorting are easy to understand, but implementation might be look little bit different or tricky. You can write your own implementation. There is no correct implementation for any sorting algorithm. Okay. There is no correct implementation for sorting algorithm. Sorting is basically concept, right? So every sorting algorithm is just a concept. So selection says I'll pick the smallest one, put it at the start. That's the concept of selection. Bubble says I'll keep on swapping to bubble up the largest element to end. So bubble says I'll bubble up the largest element to the last, second largest to the second last. That's my logic. Now you can write it in any way. Insertion set, I'll pick up one element, right? I'll start from the starting, pick up every element and put it into their correct position. Then this way, after doing insertion, or if you do it for n-1, right? So this would be still fine, right? If you run any sorting algorithm for n-1, that is going to work fine. Why in, okay, sorry. Here you have to run it till n. If you start from 1, right? If you start from 1, you can run it from 1 to n. Now running any sorting algorithm from 1 to n, or like 0 to n minus, for n-1 iterations, basically, if you run it for n-1 iteration, it's going to work fine, because if you put n numbers into its correct position, right? Sorry, n-1, the last number is automatically in its correct position, right? So if you just put n-1 numbers into its correct position, last number automatically goes to its correct position. So here we assume that first number is in its correct position, and we put these n-1 numbers into their correct positions. That's we inserted them into their sorted list, and finally we got the final sorted array. Okay. Earlier also we were doing the same thing, right? Right. So this is like people who thought of, we can do it in this way, we can do it in this way, we can do it in this way. You can yourself think of, right? You can yourself take a deck of cards, take a piece of paper, write the numbers, and today you sit down and think of how else we can sort this. Is there any other? So you might accidentally discover any one of these algorithms. They are not different, right? Not difficult, or not something that you cannot figure out. Right? If you sit with a deck of cards, if you sit with something, so you'll get the idea. Okay, this is just another way to get the result, right? This is just another way to get the result. Essentially, at the end, we are seeing some sort of result. Very like there is very slight variation of how we are doing it. Now, let's talk about this. What's the best and worst case complexity? So let's talk about like the best case. What is the best case? Let's talk about all the three cases. Best case is when the array is already sorted. So by in how much time will it tell us yeah, if the array is sorted? Okay, tell me if the array is sorted, this condition will ever satisfy. This loop is ever going to run. Is there any shift that is going to happen? No. If the array is already sorted, this condition is never going to get satisfied. A of j greater than current is never going to happen. So we are going to get O of n. So in the best case, this is O of n. In the worst case, what's the worst case complexity of this? If the array is already sorted in descending order, then we'll need to do swaps for every number. We'll do n last number. We'll pick the first. Like we'll do every time we'll swap. So then in the worst case, it is going to be n square. And in average case as well, this is big O of n square. Okay. So if you have no idea about idea about the data, right? Then ideal cases like use bubble or insertion sort, don't use selection sort, right? Because in the best case, selection, insertion and bubble are order n, but selection in the best case is as well n square, right? So if you have no idea about data, the and you have to pick any one of these three, so it would be better to pick insertion or bubble. And most likely insertion, because you're not doing too many swaps, you're just shifting elements, right? So you're not doing swaps, you're just shifting elements, and you're just doing swap one insertion at the end, right? So shifting is easier as compared to this operation, right? So this is more operations, and this is less number of write operation on array, right? So here we are having less number of write operations, but here we are having more number of write operations. So if you don't have, like, if you have no idea about data, right, what is data, how random it is, so best is to use insertion. But if you have idea about, let's say 2-3 numbers are only out of place and rest are correct, so then also insertion would be getting you the same complexity like bubble. So you can use insertion in that scenario as well, right? So insertion fits all the scenarios where you might need to think of using bubble. So in all those scenarios, insertion would be better. Or in any n square sorting algorithm, the most preferable one is insertion sort as compared to selection or bubble. Selection is used in a lot of places when you do partial sorting. Partial sorting करना है तो selection use करते हैं. Okay, that would be one optimization. So let's say that can be a direct interview question on sorting, right? You might get it again. I told you, right? Sorting is always a subjective question. So you might get a question like, let's say you are getting the results of search. Simple example that I explained. Right? It's the results of search on a Google site, and you want to create a filter that will allow the users to sort this based on the time, based on the number of site visits, or based on the top rated site or something, right? So you want to apply this. So you already have that. You have the ratings, or you have the, let's say, you have this information about the number of visits. You have the information about the last updated, right? When the site was last updated. So how will you sort? You are given only one parameter. You want to create this filter. How will you do? Right. So in that scenario, the best solution is selection. Because you can so this is like one observation which interviewer won't tell you, right? You have 1,000 results, let's say, how will you sort? So everyone will start doing in like n-log and sorting, right? Without thinking of the how Google search is showing you results. Google search is not showing you results of all the 1,000 pages at one single page. It shows you first 10, then you manually have to go through the second page, right? It is not even an infinite scroll, right? That is a concept, right, in front end which we use, which is known as pagination. If you already know it, but if not, then when the results are too large, right? So what we do is we show you small parts of it, right? And if you keep on, so either it can be like you go to the next page, we show you the next part of result, or you keep on scrolling, and when you hit the page end, then you will see then you will see a load array which will load the next set of results, right? So there you just need to apply 10 sorting. So that's a very practical example of selection sort. Okay. So since you are seeing the sorting, so you should not be get very excited, right? So always I tell you, if you see the easiest question in interview, that's the most difficult question. Okay. So the easier the question gets, the more difficult the answer is to figure out. Okay. Okay. Understood? Selection, bubble, insertion, concept wise clear?
सर insertion short का कोई practical example बोलिए.
Insertion sort, basically, if you have no idea and you have to apply sorting in order n square, then insertion is better. And insertion, there is a, I would say, if the array size is lesser, right? If array size is very low, for example, let's say 32, 64 or something, 100 size array, then insertion even works faster than merge, quick or heap sort. Okay. Because quick sort has a worst case complexity of n square. Heap sort again requires additional memory, and merge sort also requires additional memory, right? So merge sort, like heap sort, is too much logic. Merge sort requires a lot of additional memory, right? So that, because of that, it was like a paper that was created, because so in case of a small size array, insertion, even though it has n square complexity, was performing better than merge sort, because we did not were not required to create any additional memory, and there was very less operation that is required in insertion. And if you look at any other like sorting logic, so see over here how many like operations we are doing, right? Over here, how many operations we are doing over here, right? But then now look at the insertion node. This is like the smallest logic that we have written among all the sortings, right? So that's why insertion is faster for smaller arrays. We have a class tomorrow. I have not got any intimation, so I have no idea till now, right? So I will just confirm, because I need one class, right? I need one class to complete this. We have to do questions as well. So and we have string buffer and BufferedReader that we have not started yet, right? So we should be having one. I have informed it, but I'll check with the team, since we are on 24th and we have few days. So you might get a weekend off as well. Okay, well, strings can be sorting, right? He understood this, all the logic, all the best, worst and average case complexities, few scenarios where it can be used. Now it's like sorting is again scenario specific, right? You have to figure out which one should work for the best given the scenario. If you want less time and exception with space, then merge sort works best for random. Yes, merge sort is best if this is always n log n, right? Merge sort is always n log n. Okay. And so interviewer will let you use arrays.sort, and if the question is not about sorting, right, the question would be something different, and you are using sorting, so you won't ask you to write a sorting algorithm to sort it. You can use arrays.sort. Okay. Achha. Now we did all this. Now is there any other way to sort this? Yes, you can do this arrays.sort, and you just pass it the array. Okay. So this actually sorts the array. So this is one line that you have to write, and it will actually sort the array. This does it in n log n complexity, uses additional space. Internally, it is a combination of merge and insertion sort. See, sorting the array. You can give it a random array, it will sort it. It uses stim sort. Yes, stim sort is nothing but a like combination of merge and insertion sort. Right, so similar, like I gave you, right, example of insertion sort is faster for small arrays, so it will do merge sort, but for smaller arrays it will do it insertion, right? So you'll learn about merge sort in the next module, and you can ask this question, right? Why it uses, why it's faster. You'll get the answer. Now there is like a lot of sorting, even odd sort, brick sort, so many sorting algorithms are there, right? But these are the ones that you'll need. Even odd is basically, I guess is like you are picking even index numbers and sorting. So even numbers and odd numbers, something related to that which logic, I don't exactly recall, right? So yeah, there is one, I read some Geeks for Geeks article a long time back, which was even odd or brick sort. You can, it will give you idea, right? So see, this should give you idea of how sorting is. Now, if you see any other algorithm, right? So merge and quick, why can't I cover this right now? Because it requires recursion to sort it, right? Now you don't know recursion, right? So in order to explain this, I need to explain recursion, right? Because in coding terms, I can explain it in terms of like you can have a paper, you can use this logic to sort it, but you cannot understand it, like you cannot write it, implement it using code, right? Because in coding you need the concept of recursion to implement it. Okay, so I'll give you idea what merge is, right? So merge mein bata deta hu. Okay, let me give you idea about how merge sort works. Okay, so basically let's say you have an array of numbers. Okay, so how you can sort this array of numbers is, see, till now what we were doing, so we were like doing selection or bubble or insertion. What does merge sort say? See, very simple logic, right? let's say you have this 4, 1, 2, 8, 4, 5, 6, something like this. Okay. So what does it tell? Okay, let's say let's break this array into two halves. Take equal halves. This is the first array. This is the second array. We'll actually be creating these two arrays. Okay, so we'll actually need to create this array. That's why it requires additional memory. Now we'll again break this into two halves. So this will break into 3, 4. This will break into 1, 2. This will break into 8, 4. This will break into 5, 6. Okay. Now we again break it into two parts. So we break it into 3, 4, 1, 2. We break into 8, 4, 5, 6. Okay. Now once we reach to a single number element, right? Once we reach to one size array, we can start merging them. Okay. Now we can merge this. Okay. So let's say we divided it into this, right? And now we'll merge this. So when you merge 3 and 4, two arrays, right? This is something which we can do right now. Okay. Let's say you're given two sorted arrays. Okay. So this is not a question related to merge sort or something. They're general question. Let's say you're given two sorted arrays, and you have to merge them. And final array should be sorted. Okay. So you have given two arrays, create a new array, merge the current two arrays. Two arrays are sorted, so the final array should be sorted. Okay. So one idea that you can use is, okay, let's say I have two arrays, A and B. Oh, this is not sorted, right? I have to give them as sorted. Okay, let me do this. Okay, let's say you're given two arrays, equal, unequal size can be whatever the size is. Okay. Now what you have to do is you have to find out a third array, which is by merging these two arrays. These two arrays are sorted and final array should also be sorted. How can you do this? Think. So Asha, tell me what will be the size of the third array? The first array is of n size, second array is of n size. What is the size of third array?
11.
Mm-hmm.
Size of A plus B.
Size of A plus B, right? It is just the sum. M and P, let's call it, or result R. Okay. N plus M. Okay. Now one simple way is concat and sort again. Yes, that's the very simple logic that you all can think of. Ki kya karenge? Final array will create a new array, result array, which is of size n plus m. What this will do, we'll first put all the numbers in A array, then we'll put all the numbers in B array, and then we'll sort it. Okay. Acha. Copying all the numbers of A array, what is the time complexity? Big of n. What is the time complexity of copying all the numbers on B array? Big of m. Right. What is the complexity of again sorting? Right. So let's say you know the best sorting algorithm, you will be getting n log n. Okay. If you know n log n, you can get n log n. Otherwise, you'll get n square. Right. The numbers are random, you'll get n square. Right. Now, so even though those arrays were sorted, you finally got n log n sorting, n log n logic, right? Right? Where n is the size of this result array. It is not even the size of A or B array, it is the size of result array. Right? Can you do it in order n? Order n plus m.
That use two pointer, one pointer for array A and one pointer for array B, and comparing the elements of A and B.
Yes.
And then put it in the result array.
Right. So see, since these two arrays are sorted, we can use this information. So what we can do is, let's take one array. Let's say one pointer is 0, other pointer is 0. Okay. So I is pointing to the A array, J is pointing to the B array. Okay. So what we have to do is, until I is less than n and J is less than m. Okay. Until I is less than n and J is less than m. What we can do is, okay, let's take one more pointer K, which is pointing to the result. Okay. Okay. So if this is both of them are less than n, that means it's fine. If the first element A of I is less than B of J, then which word should go first into the result? if a of I is less than b of j, which number should be going into the result? I or this number or this number? 1 is less than 3, right? So I should be going into the result. So you can simply put result of k is equals to a of I. Since we have put this number, we can increase I and we can increase k. If this is not true, that means let's say this was something different, and let's say we had a 0 over here. Yeah, 0 tha. This was not true. 1 is less than this. This is not true. So which number should be going? B of j, right? So we'll copy B of j. So now, otherwise, this is not true. We can copy B of j. B of j. We can increase j. We can increase k. Achha, tell me, is it done? Will this give me the result of merging both the arrays, or should we do anything else? Think.
We have to insert the remaining elements.
We have to insert the remaining elements at the end of this, right? So for example, let's say this number is 3, 5 something and 10. So one pointer came over here, 12, right? So 12 is 12 less than this. So this entire array will get inserted. J will reach the end of this. J will become end, right? J will become equals to M, but there are numbers in the array initially, right? So the remaining numbers we have to insert at the end of array. So while if this condition is this condition becomes false and there are number in the first array, you just need to do this operation again. Okay. And just the reverse if the j array is not exhausted. If j is less than M, if there are numbers remaining in the second array, we just need to do this operation on this array. Tell me, understood this? Not? Now if we run this, I said we have already I. Okay, we get this final sorted list. Achha, what will happen if I don't write these two loops? If we don't write, so if we don't write these two loops, see, you are going to get this merging, but these last two elements are 0. It did not put the correct elements. Okay, why these two loops are important? Let me show you this. Okay, so let me do a dry run. You'll be easily able to get that. Okay, chalo, let's see. So this is too big to click into the screen. Let's check this one. Okay, see this one. So what we did here was we basically started with I equals I over here, j over here. Okay, so we checked, right? Both this 0, this is 0. We checked, is 1 less than 3? Yes, 1 is less than 3. So finally, the first array should first number should come over, first one should come over in the result, right? 1 should go into the result. So result of 0 will be 1. So this is like the result array, right? Whatever size it is, whatever number it is, first number we put it as 1. Okay. Now we increased I. So okay, now since we put the first number from the first array, we just increase I. J still remains there. J wahi reh gaya. I just changed to its next index, right? I changed to its next index. J is still there. Now we compare 2 and 3. Is 2 less than 3? Yes, 2 is also less than 3. So we put 2 into the result. We increase I, we increase K, but J still remains there, right? So we put 2 over here. J, I came to here. Now, if this number, let's say this number was 30 or something, this entire array would get inserted and this J would still remain over here. J won't move until you find the correct position for J. Right. So now we got 7. So is 7 less than 3? No, 7 is not less than 3. So we should insert 3, right? So we come to this side, we insert 3 and we increase J this time, not I. So we increase J. Right. Next iteration we again compared, is 7 less than 5? No, 7 is not less than 5. Then we go to the else part, we increase, we put 5 and we increase J, not I. J comes here. Now we check 7 less than 8. Yes, 7 is now less than 8. Now this is the correct question where 7 should be inserted. So we insert 7 and we increase I. See, We just are comparing two numbers, which of them are smaller, we just pick one, we insert it into the result, and then we move to the next one. Is 8 less than 8? No. So we like in the equal case, you put anyone, doesn't matter. You can put I, you can put J, that's fine. We are putting, in this situation, we are putting J. Now next iteration, 8 less than 9, this is true. So we put I, right? We put I index value, right? We put I, 8 gets inserted. Now 12 less than 9, this is false. So we insert J, right? We insert 9 and we increase J. Now 12 less than 10, this is again false. 12 less than 10, this is again false. So we insert 10 and we increase J. Done. Finally, J goes out of scope. So what happens when J ends? Is all the values inserted? No. There are two values still remaining in the I array. So what we have to do is, so if this terminates because of J or this terminates because of I, the other remaining elements we have to insert. In this case, the I is remaining, right? Same like, remember array addition पे ऐसा कुछ करा था हमने. If the one array exhausts, we just check the other array and we just add it, put in the remaining result. If any one of these two loops is going to run, both the loops cannot run. If both the conditions are true, we'll never come out of this loop, right? So we can only come out of this loop only if one of the condition becomes false, right? So only one of them is going to run if either first array is going to remain with elements or second array. Now in this case, first array is remaining with elements. So we run the I less than n and we put 12 over here and then we put 15 over here. Done. So this merge is only going to work for sorted, right? If arrays are given in sorted order, that's given, right? If arrays are given in sorted order, then only we can merge it, right? So if arrays are not given in sorted, see, I told you, right? This is merge for sorted arrays. How can we use if the array is sorted to merge and create a final sorted array? Okay. What's the complexity of this one? So this loop is going to run for order n, order n plus m, right? Or m if the n is the size of final result, or you can say it is big of n plus n. Okay, which is the optimal way to merge two sorted arrays. Understood? So this is a sorting question. This is not related to like merge sort or something. This is a general sorting question. How will you merge two sorted arrays? Right? Very often, frequently asked. This is even asked in interviews as well. Right? You are given two sorted arrays. How will you merge it? Right? Will you merge directly them, concat them, and sort it, which will give you n log n. But if you just use this merge, that's all. Like if you just use this thing, that information that is already given, which is to create a which is to use this sorted information, right? That the arrays are already sorted. Okay. Yes.
Like in the B array, like at the last position, like where 10 is written, if you write 20, then by this logic, 20 will be inserted before, no?
No, it won't be inserted, right? So this will not satisfy, right? A less than B will satisfy, and we'll insert 12, we'll insert 15, right?
So but when the elements are exhausted, then 15 will be inserted before.
15 will be inserted before.
No, so 15 will be inserted after that, no?
No, it won't insert, right? This will insert, A array will exhaust, J will still be pointing to here. J will remain over here. And then finally at the end, J would be like inserted at the end. See, okay. So this will only get inserted in the order, right? Because we are comparing I and J. So think out like this. You have two lists and we are just picking two numbers, right? Which is the smallest in the list. So when we are on these two numbers, we are picking the smallest two numbers in the list. दोनों के smallest numbers को pick करा. Now, which one is smaller out of them, right? Which one is smaller out of them? We inserted that number, okay? And we move to the next one. Now, its second smallest is getting compared with this list smallest. Now, which one is smaller among them? We insert that number. Once the number is inserted, then only we move forward and then we compare. This list third smallest and this list smallest. Which one is smaller among them? This is smallest. We insert this one. Now this list third smallest, second smallest, and this list third smallest. Which is smaller? This one is smallest. We insert that. We move to here. Now these two lists third smallest numbers. Which one is smaller among them? This one. We insert that. So one list can have very large numbers, right? One list can have like 30, 50. So let's say these numbers are 30, 50, 80, 90, 200, something like that. The other list is having very small numbers. So what would happen is this list largest number will keep on inserting all the numbers from this list, and this condition will never be like false. So A of I will be less than B of J for every insertion, and will insert all the numbers in A of I, and will exhaust the first array. And when we go to the second, so we'll exhaust the first array, second array J is still over here. First array exhausted, now we insert all the numbers that's there in the second array at the end. Okay. Okay. Understood merge using n plus m, simple merge logic. Okay. While loop, it looks beautiful, right? While loops look less messy than for loops. So like when you'll write software development, you'll get used to writing more while loops than for loops. Now let's talk about the question that we were discussing. Oh, I erased it. Nice. See. Okay, now let's come. Okay, let's not explain more. So okay, let's think like it is going to now. Now I gave you two strategies, right? You can divide it, you can merge them back, and finally after merging two sorted lists, we start by one single size array, which is we assume that it is sorted. We merge two of them. Then we merge two size arrays, which both of them are sorted. Then we merge four size sorted arrays, which again using n. So we have to do like each merge is order n, but we have to just do log n merges, right? Because if you divide the array into halves, it will result in log n divisions. Okay, so that's why it is n log n. Okay. So that is it about sorting. You will understand. You will again revisit sorting after learning recursion, where you'll see about merge sort, heap sort, quick sort, all this sort. If you want, like team sort is just an extension of merge and insertion sort, radix, cyclic, right? I don't know whether these two are there in syllabus. These are not required, right? These are not required. Only these are like the first 6 what I wrote over here are something which is like you can use. When to use for and while loop, if you have doubts, just use any one of them, right? Whichever one you feel comfortable, right? See, for now you won't get idea ki kya use karna chahiye, for or while. After writing code again and again, you will get the intuition ki haan, while use kar lete hain. You'll get the intuition like for use kar lete. How many algorithms is enough? I would say 6. These 6 are enough. This 6 would fit in any kind of scenario you require. This 6 sorting algorithms would fit in. Okay, in n square, in selection, bubble, insertion, right? So you won't necessarily ever use bubble. You'll just use insertion. Okay, right now I cannot even think of a scenario where you can use. It's just like if you have 2-3 numbers out of place and all the others. So this is the only sorting algorithm where you can break in between, right? There is no sorting algorithm which breaks in between. In those situations, that is fine. Here you do it, but you traverse the entire array. But if you have like sorting, this second loop doesn't run, it just confirms it. It just never enters into this swapping, the shifting logic. And selection is, I give you the example, right? Selection, where you can use it. Right, so just remember the logic. Implementation wise, you can implement it yourselves, right? If you look at like internet as well, you'll find 10 different ways to write insertion sort. Now all of them are correct because insertion sort is a logic, right? Sorting insertion sort basic logic hai. Now writing code can be different, right? There is no fixed code or this is like the best code to write insertion sort. It's just a logic which works in this particular, this is like best version average case complexity. Okay. In arrays.sort, it uses merge sort plus insertion sort, right? It is merge sort plus insertion sort, which is known as stem sort, right? A combination of merge and insertion sort. So in merge sort, right, basically we are breaking the array into size 1. It doesn't break it into size 1. It breaks it into size 30, 50 or something like that. And then applies insertion sort directly, because for a smaller size array like 30, 50, insertion sort is faster than merge sort. And that was like proven by a paper. It even compared the different sizes array, and it found out that for every system, the insertion sort is faster because it doesn't require any memory, right? So for smaller size, it is faster. For larger size, right, it goes to n square. So at that point, it breaks, right? But for 30, 50 size array, this is fine. Okay. Now, for those of you who still want some visual thing, I would suggest to use that paper to do it, or you can just search for sort visualization. Okay. You'll get a ton of sites, right? Visual algo, right? Compare sorting visualization. You can select the sorting algorithm. Let me open one of them, right? So if you just go over here, so what you can do is Just a second. How can we skip this? Okay. See, so you can select, like, for example, bubble sort, selection sort, right? And then you can go for sorting, right? So it will explain you how it will sort it. So you can say set a numbers, you can apply sorting. So it will tell you, right, this is the logic, how it is working. So you can see some like visual tools that helps you understand, right? So here you can see like it is comparing, it is assuming 29 is smallest, it is finding out 14 is smallest, swapping it, 34 and 29, it is swapping it, right? Okay. See, so 29 assumed, right? So 10 it got the smallest, so 10 and 29 got swapped. 29 it assumed it got 14 as smallest, so it has swapped 14 and 10. You can take a larger size array, that you can just increase your input size, and that will help you like see for even more larger elements. You can similarly do it for bubble sort or something. Create a, right, that will allow you to create even an array. Okay. We're not done with all the concept. We are still left with string buffer and BufferedReader. That is something which is left. So I can't start with revision tomorrow. Revision will be started next week if we have class tomorrow and we complete this, right? Because I don't see that class in the sheet in this here. Yeah, we'll have one class. I have already informed it, but I'm not sure about whether we have it tomorrow or when. Because next week we have 5 classes, so we require 4 more, 1 and 3 revisions. Okay, so we have 4 classes. We could have 4 classes in next week, Monday, Tuesday, Wednesday, Thursday. So that's why I guess this weekend Saturday class is not scheduled. TCAL will cross validate. Okay, you'll get the information by today if there is. Okay, and if there is any class, so it would be from morning 10 to 1, something like that, right? 10 to 1. So that would be the timing for tomorrow's class. So yeah, please check on the platform by today or tomorrow morning at least, right? I also want to take that because I want to complete this by this week so that we can use the remaining time to solve questions, the remaining ones. Okay. Now, what else do you have doubts, right? So I can take on the doubts now. Okay, so sorting these two, like there are 2 assignments on sorting. Please complete them. 6 questions each one. Now, since I explained all the sorting, like there is easy for counting sorts. So for example, 0-1 sorting. Like if you know the numbers are, if you know that the number are it's just 0 or 1, right? So which sorting algorithm will you use if the numbers in the array are simply 0 and 1? Selection, bubble, insertion. Given that the numbers are only 0 and 1. बबल इतना बता फिर बबल नहीं सिलेक्शन no if numbers are just 0 and 1 if what do you do if you know that the numbers are in a given range sasta hashing yes you just need 2 variables count the number of zeros count the number of ones put all the zeros at the start of the array put all the ones at the end of the array done if you just know 0 and if the array numbers are 0 and 1 right इतना पता है फिर insertion merge selection सब ऐसा कर लो right think right sorting में कभी भी easy question में कभी भी ऐसे नहीं सोचने right you don't have to think right this one is best just use arrays don't sort array dot sort is also n log n right but if you know 0 and 1 you can do it in order n right why will you go for n log n right Himalaya there is doubt let's copy this link n log n तो we'll do it when we don't know anything right we'll use memory and we'll do that right so that can be done in constant memory okay AJ number this is there Acha, did you have doubt in understanding the question? I'll explain the question. I'll not solve it now. So you can solve it. Sorry. You can solve it yourself today. Try it at least one more day, and then we'll discuss it tomorrow. So 0 and 1 are not AJ number. What are given a discussion on a new type of number that they called AccuJob number or AJ number. The following criteria to define an AJ number. 0 and 1 are not AJ numbers. These are AJ numbers. Okay. 2, 3, 5, 7. Okay, so any number not divisible by 2, any number not divisible by the numbers in the point 2 are also AJ number, not divisible by the numbers in point 2. Take any number that are not divisible by over here, those are AJ numbers. So basically these are prime numbers, right? So these numbers are prime numbers. So any other number that is not divisible by these numbers is also prime, right? So you have to basically find out the prime numbers. Okay. So what are AJ numbers? These are nothing but prime numbers, right? So AJ number is nothing but prime numbers. Okay, let's check, right? What it has asked. Deepak has loved AJ numbers. Is hearing Gautam throws him a challenge. Gautam gives Deepak a string of digits. Deepak asks to find out the number of AJ numbers in the string. AJ number once detected should not be a substring or a superstring of any other AJ number. Okay. So there is a constraint. If you pick one number as AJ number, you cannot use that part of string to create another AJ number. So for example, here 499, so 499 is also a prime number, 991 is also a prime number, but 99 is overlapping, so you cannot choose both of them, right? Achha. So further AJ number can be formed only by substring of string. Now in 481 you cannot take 41 as AJ number because 41 is not a substring of, so it has to be substrings. So it's बहुत easy. Now, should I give you one hint? There is only one hint that I guess you all require. So it is prime number. How many of you figured out that this is prime number? So AJ numbers are nothing but prime numbers. That is not any mystery, right? वो prime number है. Any number that is not divisible by this are prime numbers, right? So any number that doesn't have any prime factor is basically a prime number, right? If you figured this part out, the second part is basically you can have to pick numbers in such a way that you create most of maximum number of AJ numbers. Now, how will you pick numbers? Any ideas? Think. So it should not be overlapping. Achha. So what is the maximum number of AJ numbers you can form? So given any string, so let's say this is a string of 5 size, what's the maximum number of AJ numbers you will get? You will get at max 5 AJ numbers. Given the constraints, you cannot overlap. At max 5. How did we get 5? Because you pick each digit and as a AJ number. Each digit is a AJ number, so you get 5, right? Now, since the digit cannot overlap, so you cannot pick 2 digits, 3 digits. And if you pick 2 digits, then you will be able to form lesser number of AJ numbers, right? So you first check with all 1 digit. If you like if you form 2, 3, 1 digits AJ numbers, that's fine. Then you pick 2 digit AJ numbers, right? And when you're picking 2 digit, you should not pick those substrings which you have already picked as 1 digit, right? Then you can pick 3 digit. You should not pick in 3 digit all those substrings that you have picked in 1 digit or 2 digits. Understood? Not? Yes? No? So firstly count by using 1 digit, then count by using 2 digits so that you don't have overlapping. Count by using 3 digits so that you don't have overlapping with the results. If caught, then fine. 1 digit, 2 digit confusion. Take a think, right? So this is something you have to think. ये तो sorting से related भी नहीं है. How is it just related to sorting? Sorting से तो related नहीं लग रहा. This. अच्छा, C-verb Eratosthenes मैंने नहीं बताया ना. I've not talked about C-verb Eratosthenes. That is something I've not talked. ठीक है, वो भी करना है. चलो, I'll write this somewhere over here. Oh. I don't know spelling क्या है. यही होगा C-verb Eratosthenes. हाँ, वो कुछ Greek name ही है. Right, this is a very like easy logic to find out prime numbers. We'll discuss this, right? This name is just complicated. Logic is very easy. Okay, so this is like optimizing. So let's say if I tell you to check any prime in a constant time, whether the number is prime or not, so this will help you figure out that. No, the name is just complicated, right? The logic is very easy. Do we have time today? Should we discuss this? कर सकते हैं. Hurry up for it. 15 minutes. I require 15 minutes to discuss this. अच्छा, परसेंट भी नहीं बताया. परसेंट कर लेते चलो पहले. Percent is easy. देखो, percent is easy. चलो, I'll not discuss the platform questions today. Right? Take your time, complete all of them. एक array list में question है. There is only one question in array list. String में we discussed a lot of them. There is only one, I guess, remaining there. Sortings, all these questions we'll discuss together. Okay, we'll do it in this weekend. We also will use, like, say Sunday we'll have definitely a class, so that class also will discuss few questions. Okay. We'll try to figure out that. They can try to figure out C of rest of things. Let's see. So what is parseInt function doing, right? So parseInt is very easy. Let's say you're given an integer. Like this will only work if the number is string represents an integer, right? So what do we do over here? So let's say the string is representing an integer. What we can do is we need to convert it into an integer. Let's say the parseInt function basically converts a string to an integer, right? So if you do this operation, system.out.println, it is integer dot parseInt, and you can convert, like, pass it any string. What it will do is it will convert it into integer. Okay, actually this is not just true for integer. You can convert string to any other data type. So for example, let's say you want to convert this to double dot parse double, and you pass it a string which is having decimal number. It will actually parse this into a decimal number. Okay, see, what if, like, let's take this one. What if the string is having this value point something like this? So this can actually parse this by converting the string to a double, or this can parse it by converting a string to integer. Oh, sorry. This we can comment. Just need to run this. Yes, see, so so this is a classic example of memory leak that was there in that site. So for example, the site that I had opened for visual sorting, right? So that was freezing my screen. As soon as I close that tab, my screen is again back to normal, right? So that is a classic example of memory leak. So whatever logic is written in that site, there is somewhere they have used a lot of memory, and that is even running in background, even though I don't interact with the site, and that is slowing down my system, right? That was freezing my screen. I was not able to like perform actions like click or hover or move things without lagging it, right? So that was one example of where we should have optimized memory. Online GDB, I have rarely observed this as memory leak, but yeah, that was one site. You can even experiment that. The site that I opened, right? You can try to keep open and like keep it open for quite a while. We had opened it like 10-15 minutes ago. Now check that your site would start performing weird. Okay, understood this. So basically this is parsing. Now can we write it ourselves? I'll do it for integer, and I'll like you can try it for other numbers as well. I'll leave the difficult part to you all. Okay. Now how can we create it? Let's say we want to create a number A. We'll initially put the value 0. Okay, what we can do is we can traverse this string. Let's start by for loop for int I is equals to 0, I is less than n, I plus plus. Okay, every iteration what we can do is A is equals to A into 10 plus result of I. Is this going to work? Result of I is going to be 1. So 10 plus 1, or 0 into 10 plus 1, right? Is it going to work? How many think this is going to work? So 0 into 10 plus 1 will get 1. Next iteration, 1 into 10 plus 1 into 10 plus 2, it is going to be 12. Then 12 into 10 plus 3 is equals to 123. Then 123 into 10 plus 4 is equals to 1234. Now this is S number. Does this work fine? Is it correct? Okay, everyone thinks this is correct. किसी को भी प्रॉब्लम नहीं दिख रहा?
करेक्ट नहीं है सर, वो कैरेक्टर है और इंटीजर हो रहा है.
Right. So this is not character. This is ASCII. Right? This is ASCII. This is not going to give you 1, 2, 3. You have to do this, right, to get the digit. Yes, subtract 48. Now this will give you the result, right? Reverse नहीं हो रहा, right? यहाँ पे reverse नहीं हो रहा. Result. Oh, sorry. Result. Oh, sorry. What have I taken result? This would be S of I. S dot character. Okay, now we are getting 1, 2, 3, 4 as a number, and this is what parent is doing. Parent यही कर रहा है, going through the entire string. We are not reversing, right? Reversing, see why the number के case में this was reversing, because we are putting the last digit. हम number के case में when we are doing a digit traversal, when we are doing %10%, we are getting the last digit, then second last digit, then third last digit. But this case we are giving the digit from the start, right? We are not giving the digits from there. Okay. Now try to do this for double dot pass double, float dot pass float, long dot pass long. Right, long dot pass long is exactly same, just that this is a long number now. Okay. Okay. Or else character dot, no, character is not there. Boolean dot pass boolean also works, but that is a boolean number, right? So that is work differently. You can do it for integer, double, float, all these at least. Okay. Okay, got it. What is the generic meaning of parse? I heard this term while downloading something. So parse means conversion. Parse simply stands for conversion. Okay. Parsing basically means conversion of something to something else, one data type to another, okay, or one format to another. So parse means conversion. Parse stands simply for conversion. So when we say online, we want to parse this into this, we want to basically convert one format to another, like say JPG to PNG, string to integer, integer to float, or something like that. Yes, there is a parse tree. Yes, we create a parse tree while passing it for conversions. We use parse tree, so there is like implications there, right? So we have those things. In double, you have to also take care of decimal. If the number, if that string has a decimal point, then you basically need to. So here I have assumed, right, okay, this is going to be number, and if it is not a number, then it is going to fail. But this % throws you errors. If you give a character in between, that will give you error. How can you write that logic over here? If this is a character or something, you should stop in between, and you can say that this I cannot convert this. This is not a valid number. ASCII, right? You can just check if caret I is in the range of 0 to 9. If that is fine for every character, you can convert it into integer. Right? In case of double or float, you are allowed to have only one decimal point. If there are multiple decimal points, then you need to throw the error that this is not even a this cannot be a double or float number, right? So you need to check for each character whether it is a digit or whether it is a number. Now, if it is within that range, that's fine. If it is not in the range, then you need to throw the error. Okay, understood? Clear? Okay. Okay, so now complete all the sorting questions, complete all the string questions.
Share the link, sir, please.
Yeah. So I'll share this link. Remaining जो questions or whatever doubts you have, will I think we have one class this week, or if not, then we have 4 classes. Okay, I can just tell you that we have 4 classes remaining, 3 to 4 at least. At least we require 2 classes to complete things, and 2 revisions at least. So that no, not this one. I will not cover this. I require some I require 15 minutes. It's not difficult, just the name is tricky. Otherwise, this concept is very easy, right? If we complete this, then we'll be completing all the basic fundamental algorithms or concepts that's there, right? We'll be touching everything, just StringBuilder and BufferedReader, so that you'll be prepared for advanced data structures like linked list, stack, queue. But again, since you know memory, those things would be very easy for you to understand, right? The memory follows same rule. You have to tell how much memory you need, and it will give you, right? No one can violate that. No data structure can create an infinite long data structure where you can keep on inserting and it will never overflow. That cannot happen, right? That is fundamentally not possible. So every data structure has to follow this. It's just that we have used different ways to bypass. For example, array list, maybe double up, right? So we have used our ways to bypass it. In linked list, we just create one element, and then we tell that you know the address of the next one. The next element will know the address of the next one. Okay, so we have created a data structure like that. In trees, we just each element knows the address of 2 of them, right? 3 of them or 4 of them, right? So every data structure is following this fundamental rule, just that in memory it is little bit different how it is created. how we have created it, and logically we see them differently. Okay. Tomorrow contest, I'm not expecting too much sorting questions, but I'm expecting 2D arrays, strings, array list, all these questions would be there, right? So complete these all questions. Buffer reader, string builder, this won't be there, I guess. So sorting, there might be something like basic sorting questions that might be there, right? Okay. And you might get questions for like from the previous parts, like arrays, loops, all those things you can get. Arrays, 2D arrays, loops, nested loops, whatever you have covered, those questions can definitely be there. Tomorrow is contest. Every Saturday you have contest, or just that the first Saturday of week is you might not have one, but apart from that, every other Saturday you have a contest. So this week also you would have. Next week you have module, right? Next week you have module shifting test. So next week there's not a weekly test, that's a module test, right? Okay, so we have time, right? And this for those of you who are like who have doubts in the previous topics, you want to master them. Now first complete all the assignment questions. Right, assignment me easy medium questions, right? You have easy medium questions. If there are questions remaining, right, from the previous one, you want to go for more advanced questions. So you'll be left with, right, 5-6 days for before the module test is there. So use that 5-6 days to solve 30-40 questions on all the topics combined that we have covered. So that will give you more idea. You don't have to, yeah.
Sir, module test में mock रहेगा?
Mock means as in?
Mock interview है module test में कोई?
Module test के बाद you have one module shifting interview. I guess there is one interview there, right? एक interview होगा. Which interview is very easy, right? Interview is just will ask you questions based on this concepts that we have learned in this. So interviews are generally easy, and interview questions are generally easy as compared to the module exam questions. That's if you have done assignment questions, you have cleared the module exams, so you would be easily able to clear that interview. Vocally or coding round, so it is a one-on-one interview, similar to like how your interviews for online like a job would look like, right? And fire, but at the end of some topic becomes smoke. No issues, right? We'll keep on practicing, we'll keep on improving, right? See where we started, right? We started with fundamentally if else, and see last 20 days, right? We covered so much ground. I don't think you would have covered these topics in this much depth even in 6 months or 3 months, right? If you would have learned it, if you have Googled it, if you have searched for online content on web or anything, you would not have found this much depth in each topic, be it memory, be it questions, be it practical implications, or what's the interview perspective of this. Because in like in recorded thing, it becomes very difficult to watch through this. If I create a 3-hour recording and I upload it, I would say 90% of you won't even look to it, right? But since it's live, it becomes interactive. You can ask your doubts, you can ask the doubts on fly, we can address it, we can revisit them again, we can go back to some previous topic. That's become really engaging for you all, right? If I put this thing recorded, right, as live on YouTube, no one is going to watch, right? Because this is going to be boring, right? If something is skipped, you don't listen to this, you can't go, you have to go back, see it. Okay. Okay, so we are almost very close to completing the theoretical parts. Now gear up, right? Even if you have not geared up till now, just gear up a little bit for the next 10 days, right? Until you have done with the module test, then you can relax for 2-3 days. But until the next module test, gear up for the next 10 days, complete all your assignments, like ensure you have completing all your assignments, appear for the like weekly contest that you have, that will give you practice for the final module test. And if you are done with questions, if you are having time, don't say that, okay, we are done with assignments, we don't feel that you don't have anything to solve, you have gym, right? I told you assignment is just the starter or the basic that we want you all to at least solve. We have put easy, medium, and hard questions on each variation, but solving 12 questions on sorting is not enough, right? You have to solve 20 questions, 25 questions. So 12 we have given, at least this you should solve. After that, go to Zim, practice more, right? Achha, so spiral matrix was something which we discussed. Spiral matrix 2, there is error in the test case itself, right? So I guess that is not going to work even if we solve it. So there is a error in the test case. Apart from that, like the normal spiral that will solve. Okay, so jo bhi remaining question again, I get one question somewhere here there we have left out in the assignment, so that we'll discuss and we'll complete them. Okay, So tomorrow we'll use just, if we get a class, we'll just solve questions. I might not start with string or BufferedReader. We'll do that on Monday. Okay. Or if we just need 1 hour for it, right? So if we can use 1 hour to complete that if possible. Okay. Yeah. Thank you, everyone. Okay. Take care. Solve the questions. Good night. I'll see you all again tomorrow. If not, then on Sunday, definitely. Okay. Bye-bye. Good night. Take care.
No.